Give me 1 minute to get the YouTube stream started. All right, there we go. Okay. Now, I love your name, and I'm going to insist on pronouncing every last letter. And let me see. Ooh ah 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 ooh ah. There we go. See, does any other streamer insist on pronouncing every last letter in your name? But evil dawn summoning ritual, you know, maybe. Welcome in. I think I've seen you around in other math streamers chats. Oh, good thunder. But in case you're not aware, there's a whole little community of us math streamers. Here I do both math help and I do math help streams, and I also do video game streams. So my math help is Tuesday, Thursday, Saturday, and video games are Wednesday and Thursday, just so you know what to expect. I forgot to put an announcement in my Discord for what's happening tomorrow. Yeah, and so on my math days when I don't have questions from chat, I normally will do some kind of studying to help fill in the time. And because I'm disorganized, I'm gonna write a quick announcement in my Discord because I wanted to. It's fine. No, never mind. I'll do it later. Change your name to Troll SB. You have to wait 55 days to change it back? Nah, I think it's the perfect name. Zach, thank you very much. Welcome in, everyone. Nice job on the data analysis. Hey, Obi. And Gold, hello to you. The killer rabbit. Oh God, I'm trying to get okay, there we go. So yeah, let me see. Yeah, I was just pronouncing all of Ooh-ah-ooh-ah-ooh-ah's name, and like every last letter, and I guess Thunder is clipping it. Yeah, a raid on Twitch is basically at the end of your stream. You don't have to, but you can choose to send everyone over to someone else's stream and kind of like, I'll say hi and I'll watch, or if you want, you can just come along for the raid and click off, or do whatever you want. But basically, Zach or Eats Its Way Pie just ended his stream and sent everyone over my way, which I greatly appreciate. It's got a rhythm. I should be able to find the link if it's on my channel. Give me 1 second. Oh, you put it in the Discord. Okay, that makes it easier. I'll bring it up and play it on stream, you know. We gotta see this. Oh, or yeah, I can drop the link there. This is the level of that's the level of comments that I make. That's what you have to look forward to on this channel. And I was like leaning in because I was literally like dragging my finger along Uwa's name to make sure that I got every letter. Watch it for 24 hours straight. Yeah. Shimoda, stop making me dance. I'm at work. Yeah, it's a perfect time to dance. But yeah, so if anyone has a math question, let me know. I don't think I have any that are queued up here. So I'm going to probably fill in with some electricity and magnetism for this reading group that I've been doing. Oh, you want to talk about vector projection? I should have paid more attention when Zach was explaining it the other day. Okay. No, I saw my idea for how I could explain it, so I'm just gonna do that. Oh, that one. I don't know if I'll be able to do that one aside from numerically. Like solving algebraically, I'm not sure. All right, but Thunder. So yeah, in that one problem, they were doing vector projection, but much like the eigen vector problem that we were just working on Tuesday, they just didn't want to call it by name for some reason. But so I guess before I even talk about what a vector projection is, do you agree that for any vector you want... Oh, am I already in trouble? Isn't the same problem that you were just... Oh, yeah, because Zach was just working that same problem too. The 90 plus alpha. Oh, you want to try it? Sorry, I didn't see who said that. No, you're completely fine to play this as much as you want. I just started to associate that with me doing something wrong. I'll have to go and revisit your work, Thunder, to see if what you did exactly is valid. But just like get to the concept of vector projection first. I think you hopefully already know and you agree with that. If you have any vector A, you can express it as the sum of two other vectors if you cared to, using this like tip to tail like method. Like A is equal to this vector plus this vector, right? You can call it like B plus C. Yep, okay. So now for a vector projection, you know, we have this vector A, and we're basically trying to find a particular B and C. Let's say we now have just like two general vectors, and we find the projection of A onto B. We're basically trying to find we can name, you know, I'm doing terrible at explaining this. These two vectors could be basically anything, and when we're doing a projection, we're going to choose a particular vector that goes parallel to B for our first vector. And then, you know, this other vector can be whatever it wants, but we're interested in this one that's parallel to B. And we would call, like, this part of the vector the component of A that is parallel to B. And then there's also this other component that's perpendicular to B also. And I think the notation, I always get the notation of this backwards. The projection, I think, of A onto B is how you would write that parallel vector. And that idea of a projection comes up in many different contexts. Hey, Yanis, thanks for confirming that. Dot product? Yeah, it's very related to the dot product. Oh, wow. I'm gonna laugh every time I say that. Because like the projection, like the formula for it involves dot products. I'm getting listened again. 8 Ubuntu errors in a row? Oh, what are you doing, Obi? How do you get the perpendicular? Yeah, so the dot product, it can mean many things, but one of the things that it can mean is related to the projection, as Yanis says. And for how to get the perpendicular component, I bet you could just do A minus the projection. Just say, oh, but in 50 days you're gonna change it. I vote you keep your name. I like it. Don't quote me on that subtraction part, but well, let me start to Google things now. But that explanation is what I wanted to say before. It's like that's like the fundamental idea of what's actually happening. Really? Wait. No. I did get no. I got the notation backwards. I should have done subscript to B in regular A. This notation is always confusing to me. Okay, yeah, and I can pull back up what you were saying. I saw you messaged me, but let me just look at this formula. So this is where the dot product comes up in relation to, oh, finally, I found where the best viewers are. They're at that random link. That's amazing. I was looking all over for where the best viewers are, and I'm glad I finally have the answer. Okay, anyway. Okay, and you're saying it's also V minus projection? That would make sense, like with the geometric interpretation. Okay, yeah. I'm glad that my intuition there was right. You already have the best viewers. Thank you, Fembox. I think it's a self-compliment, but you know, I agree. But yeah, so I think the Thunder, they're doing this exact formula. They just didn't have the left side as equal sign with projection of U onto V. I hate, no, of V onto U? Oh, wait. No, I hate this. This notation, it never makes sense to me. But anyway, let me look at what you were sending me. So let me bring up the actual problem. This is one I was struggling with, I think, a lot last week. It was number 15. That's the answer key. And Thunder had this idea of messing with things. Why is every single master doing vectors to begin the stream? I don't like doing vectors. I mean, well, vectors can be fun. Just the way that Thunder's problems are worded are kind of terrible. But I'm doing it because Thunder's asking the question. I wouldn't have started. I don't intentionally start the stream with vectors. It's just whatever's being asked. There are fun things that you can do with vectors, but Thunder has to do math with like both hands tied but behind their back, I guess. Solve your equation. I don't know how to solve it, and it seems like more of a for fun question, and I prioritize doing like homework help like this. So we're given the velocity, the initial velocity vector before it hits the wall, and then the velocity vector after it hits the wall. 3-watch streak. Ooh, nice, Viv. Thank you. I don't know if I'm going to try that one either. A unit vector in the direction of the impulse received by the sphere. Okay, yes. And so oh, Thunder also has a 3 streak, nice. So yeah, the impulse vector is going to be perpendicular to the wall because that's the part of the trajectory that's changing, I guess. That's probably a better way to say that, but Twitch tracks your watch like streak, so Thunder and Viv have both watched 3 streams in a row. And yeah, you get, for having a watch streak, you get plus 350 like points, or the coffee beans. Yeah, you get free coffee shipped right to your door. And so with that, you can redeem more like set sound effects and stuff like that. Or you can make me solve a Rubik's Cube, or I got a few things in there. It's 10 p.m.? Oh, okay. That's fair enough. Hope you sleep well. You got instant coffee and almost unfollowed? No, I would do the opposite and send very expensive beans to to your door, and then also bill you. You have to do CS the entire day today. Oh no, no math. That sucks, Giannis. What was happening with this again? Roblox math quiz? What? So yeah, we were trying to find. Wait, so is this answering? I forget, was this for part A or for part B? This angle stuff. I have to read your explanation. Cosine 90 plus alpha is the same as sine alpha. That, oh yeah, I think it's negative sine alpha or something. Like, I remember there being a negative sign that was off with that. I thought, is this for part B? That's right, we're trying to explain this setup. That's right, so they were dotting the initial vector with the unit vector of the impulse. Oh my god. Oh, this is cheap viewers. If you don't want the best viewers, that's where you can get cheap viewers. Oh my god. Dude, those things, there's been an epidemic of those things recently. You're cheaper? Yeah, after I banned the person saying the best viewers, they're like, oh, this person's a cheapskate. Well, let's try the cheap viewers one on him. Cheapest viewer around. Real viewers over cheap ones, yeah. Twice today, I'm popular. Apparently I am, Zach, yeah. No, I'm just trying to remember where this part is coming from. So when you dot the initial velocity with the unit vector of the impulse, you're getting the magnitude of the initial velocity that is parallel to the impulse. And then we're multiplying that magnitude by the unit vector of the impulse again, just to scale the impulse and figure out what the actual impulse is in vector form. So I just wanted to have that in my back pocket, and then the I and J notation is unreadable. Oh, I mean, I guess you two are two peas in a pod. I default to having like the angled brackets with commas. I don't mind the I, J, and K notation that much, though. Yeah, that is a flaw with the I, J, and K stuff. Okay, so yeah, I like Zach's format there. And so you start by considering this 90 plus alpha angle here. If we draw this vector going all the way through. Oh, as a literal like matrix? Yeah, I mean, that's cool too. It's probably a better reminder of what it actually is, to be honest. it can be a little annoying if you don't have to do that much like linear algebra with it, I guess, which is why I like the angled brackets too, but it's basically the same thing, just a transposed matrix or vector. Bracket notation, join the chat. Oh, E1, E2. Well, what's wrong with just going through the entire alphabet, Yanis? For a 26-dimensional vector. You know what? Let's just cosine pi over 2 plus x. Okay, yes. So cosine of 90 plus x is negative sine. R27 Cloud wants to know what you're doing about it. Oh, well, that's the great part, Zach. Then we start using Greek letters too. Because that's just what we always do, and then we end up with a million uses for each Greek letter. Hey, syntax error. Because you can make up your own symbols? Yeah. Arts of the 150 now called? Well, we can start using the Chinese alphabet. If you run out of characters there, then you're really in trouble. I guess Mandarin is a better term, right? But that's like over 1,000 characters, I think. It cancels as a dot b is negative. It does. It doesn't. Well, I guess I don't know the definition of alphabet then. Five I minus. Oh, interesting. Yeah, I've heard the term nabla before, but I forgot what it means. I think it means like something else also. Thunder, I forget what the thing you sent me is doing. Isn't that del, the upside down triangle? Nabla is the gradient? Oh, it's an AI assistant. It's a cosmetic. Oh, I was told this is del. Like D-E-L. Funny. So confused how you get the perpendicular component when you use the dot product here. You're supposed to get another parallel component. But we want the perpendicular component. Del is also used for the nabla operator. Okay. Yeah, that's an unfortunate typo. I think what we've done is probably valid, just maybe a little unnecessarily complex. I think you've done valid math though as well to get to where you want to be. We want the... Wait, you thought this would give you the parallel component. Not for how you've defined alpha. Alright, see ya, Owawa. I should just have the clip of me saying your name on a soundboard so I can just play that instead of saying your name. Yeah, if you're defining alpha as this angle, you have constructed it so you take the sine of this alpha angle, which is going to be perpendicular to the wall because it's opposite. So that's why I think the thing that you did is also valid. It's maybe a little bit weird, but I think it's valid. Isn't the angle the other way? Like, you're like, it's the same measure. Which is the really the only thing that sine cares about. I don't think that's that important. Your first girlfriend turned into the moon as well? Yeah. Wait. Oh, okay. Um. I think what you're doing, Thunder, is you're taking the sine of alpha and you're getting the magnitude of this part over here, and then you just need to ask yourself like if you need to manually flip a sign to make sure you're pointing away from the wall and not like into the wall. But, like I think this is fine. So this gets you the magnitude. You can now multiply this magnitude with the unit vector of the impulse. Actually, oh yeah, so that's why the magnitude is always going to be positive, and you're just going to multiply it by the unit vector of the impulse in order to scale this impulse vector that already points the right way. So what you've done here with all this alpha stuff is like this first component here. And now you need to multiply it in with this part here. Okay. The original question was here, Viv, number 15, part B. It really comes up. Oh, okay, that's good. And so we were looking at the solution to it and trying to explain it, and Thunder came up with a different way of doing it than the book did, which I think is also fine. We're trying to like unpack it and make sure that it was valid. Okay. So yeah, if anyone else has questions, let me know. If not, I'm gonna, I guess, go to studying. Oh, okay, you have another question. Distance from point to plane. Try to remember how that works. Yeah, it's a pretty common question. If you want to send it to me, please do. There should be just like a formula to do it automatically. I was trying to figure out the intuitive way of how you would solve for it, but Oh, you might use the distance formula and differentiate it. Okay. Apparently it's the dot product. Hmm. Yeah, Yanis, I don't have this memorized. I was trying to basically work through the logic that you just said in my head, but I couldn't quite get there. Use the line normal to the plane through the point. Yeah. And that's easy to do because planes are defined by the normal vector. This intersects the plane in one point and determine the distance from that point to the starting point. I just don't know how you line up that normal vector with the point, I guess. Oh, you got it? All right. I'm glad you saved me from having to like yeah. Thank you for saying that, Yanis. Because I know I would just skip right down to doing the formula, but or you know, I just Google the formula when I see a problem like this. But yeah, I don't think it's that hard to just construct this formula if you actually know what you're doing, unlike me. It is a little bit annoying, but I think either way, you're gonna end up with the same thing if you construct it yourself or just skip straight to it. Oh, actually, Yanis is here. I I feel like Yanis missed out on so much of the algebra that maybe I'll do algebra first, and then we can save the E&M for later. I still haven't read through chapter 4, though, is my issue. I think I'm towards the end, though, so maybe I could just read through it. I was just skipping over the proofs if I remember right. I'd rather look at them off stream. You build in problem 8. Yeah, I haven't had the energy to work more on problem 8. That's one that I want to do. I want to try going down the path that we kind of set up off stream. I think it's just too hard to follow through on problems this challenging on stream when people are like putting in their own ideas and I want to like respond to them and think about them. So I was looking through some of the later ones, and like from 50 on, there's some pretty interesting looking problems in the exercises or whatever the second half is called. So, and they're all like 1 or 2 stars. So when I do switch to E&M, I might try some of these. I mean, there's so many theorems and corollaries in this chapter. I'm sure I'm not going to keep them straight. The order of A, B, N, then the group generated by A is equal to the group generated by A to the J if and only if their GCD is, or the GCD of N in J is 1. And the order of A equals the order of the group generated by A to the J if and only if their GCD is 1 again. Okay. Get 750 million. No Feynman's technique and no partial fraction decomposition for 3 days. I don't want to do those things anyway. That's like asking me if I get $750 million, but I don't get hit in the head with a hammer. I would take that deal, yeah. I was misunderstanding the question, but like, I don't even know Feynman's technique. Like, I've seen it be done, but I don't remember how you actually apply it. Feynman's rule? Is that pre-tax check? It's still free money. You know, can I contribute it to my 401k instead? Technique sounds much cooler than rule. Oh, wait, you're being serious with the Roblox math thing, Thunder? You're gonna need to change a base there, I guess. I think you're just memeing. I was like, oh, I don't know what Roblox math is, but... Let me show you how the formula looks. So if you have log base b of a, you can choose any other base you want and do log base c of a over log base c of b, basically. No. For logs, no. That's how you know that you're doing higher level math, yeah, so you go to vector spaces. Yeah, so you can be anything you want. So I would probably keep this as log base 10 and change this one to be log base 10. So do log base 10 of 1,000 over log base 10 of x. And you probably get something that's solvable. Do you want I can show it on the whiteboard, I guess. Unless you have it anyway. You got it? Okay. Wait, you do need the... I mean, okay, let's play against Wolfram Alpha and make sure that there's nothing weird. Okay. Like, it seems pretty solvable. I didn't really follow it through all the way in my head, but... Let's make sure that it comes up with something that's not completely unreasonable. It doesn't solve for, oh, is this, is there no solution? You might not get a solution, Thunder. This thing never passes through 0, apparently. Is it not called change of base in English? Oh, interesting. You got 0.1. Change of rings? Oh. Oh, but that's for, not for this log thing, that's for... Oh, minus, oh, okay, okay. Okay, well, I guess there's 2 solutions. So 0.1 seems reasonable and 30 something. Oh, 1/10 and 10 root 10. Okay. And 1/10 is 0.1, so I don't know where the other one comes from, but there you go. Back to algebra now. I called it inaudible. So I feel like Giannis has missed out on the algebra talk for like a couple of weeks, so. Change of rings. He didn't have time to study this. Let's see. I assume this is like algebra stuff. Coefficient ring to another. Okay, yeah. Yep, these are symbols, all right. Induced module, co-induced module. What do they do to your precious algebra? Thunder, if you get, or you know, in university, if you see any class that's called algebra, you should generally just be scared of it. That was my experience, at least. In higher level math, algebra means a whole bunch of like extra things. Induced algebra. Depends on the person making the or I guess inducing the algebra, I guess. I don't judge. Oh, functors as well? Alright, that's all beyond me. Okay, so try to understand this example. So define generators of the subgroup of order 9 in Z36. Is there actually a Roblox math quiz? Say it ain't so. Oh god. All endings? No, I'm not doing this. Yeah, I'm not playing Roblox. I had enough of that as a kid. It makes me cringe now. Extreme mode hard math quiz. It's intense. You know, I'm sure it's a good thing that it exists. Like Roblox, it did teach me to code as a kid. But I have no desire to go back to Roblox at all. Very bad at group theory. Really, Yanis? I feel like you're always like talking about like rings and like I've seen you work on like the category theory stuff, so I just assume that this is like amateur stuff for you, I guess. It's like, what type of math is your favorite, I guess? Roblox child labor for the yikes? uh, I guess so. Yeah, when I was playing, all the game really provided was the engine, and all the actual content was up to the people playing it. Which is kind of a really good business idea, but well, if you take out the ethics, I guess it's very like convenient for the person running the business, I guess. You want to do algebraic geometry. You need commutative algebra, so rings, modules. Oh, interesting. Okay. Yeah, I feel like people have talked about doing algebraic geometry before. I can't remember who though. Somebody made a mod that made millions for the company, and he got basically nothing. Oh, that sucks. I mean, I've heard stories of modders for games getting hired to work for the company, which is like, uh, I guess like a happy thing. But like when it's just like a kid that's like doing all that, it's probably not good. You know, definitely turn up there as well, but mainly ring-related objects. Yeah, I guess I just think of rings, I guess, as an extension of groups. And so a lot of things that rings do will also apply to groups, or, you know, it's or I guess like maybe groups are like single variable algebra and the rings are multivariable algebra, where like they build on each other in that way. But maybe it's not quite that direct. I'm trying to figure out like how they're actually applying corollary 3. So we want all this subgroups of order 9 and z sub 36, and they manually find that 4 is such a generator. We have from corollary 3 of theorem 4.2, they're all elements of z sub 36 of the form 4j, where the GCD of 9 comma j is 1. That's the part that weirds me out, because corollary 3 talks about the order of the original group, 36, but then we're doing the GCD with 9. So what's up with that? I should make sure I'm reading the right corollary. It's 4.2 corollary 3. Yeah, no, this one is it. I think abelian groups, sure. Modules of vector space are just abelian groups. Oh, interesting. So you're dealing more with the abelian stuff. Okay. Or if you do have group stuff, then it's more abelian, I guess. Big brain me. I feel very small brain right now. Oh, I guess in this case, A isn't Z sub 36. Or it's not the original group. We're taking A as the group generated by 4. Then why are we... And it's order 9. So that's why we're doing the GCD of 9 comma J. And all the generators are of the form 4 times J because they can all be written as A to the 4th to the power of J, so the 4 and the J multiply. God, okay, that... they did not spell it out, but that's kind of fair enough. Complex numbers and matrices in the Roblox math quiz. I feel indifferent. I feel no closer to getting back onto Roblox. Oh, that's a big yawn. If that encourages kids to learn math, though, then that's great. What's the Riemann hypothesis? And Roblox keeps the money of whatever kid solves the Riemann hypothesis. 90% share? Oh, that's very generous. 99%? I mean, honestly, putting it into a game is a good way to encourage kids to actually try to do it. Maybe there'll be some, like, prodigy kid who figures it out. 1,000 Robux! What's 4 times 8? 32. Okay, I was worried that we'd go over 36, but we're good. Find all subgroups A of order 9, where the order of A is 36. We have A to the 4 to the 1 equals A to the 4 to the 2. Okay. I wish they put this sentence like right between these two sentences. That would have... This is what I was just trying to figure out by scrolling up and down between the corollary and the example problem. By combining theorems 4.2 and 4.3, you can easily count the number of elements of each order in a finite cyclic group. The number of elements of each order in a finite... What does that mean? The number of elements... So, are they saying that you can count the number of these? So, 1, 2, 3, 4, 5, 6 things of order 9, I guess. Oh, and it does match with the table. Okay, yeah, $10. For convenience, we introduce an important number theoretic function called the Euler phi function. let phi of 1 equals 1. And for any integer n greater than 1, let phi of n denote the number of positive integers less than n and relatively prime to n. PHI. Greek letter phi. I think some people pronounce it phi as well. I think I've heard both ways. The number of positive integers less than n and relatively prime to n. Which is really all that was happening with these coefficients of 4. Every number relatively prime to 9 and less than 9. By definition of the group U of n, the order of U of n is equal to phi of n. Wait, isn't it also true for Z sub n? Maybe not. It just happens to work for this one, apparently. Unless I'm misinterpreting what they're saying, but... The cardinality of a set is the size of a set. Just how many things are in it. And that's allowed to be infinity depending on the set. And you can actually get a result that some infinite sets are bigger than other sets that are also infinite. Which is weird. They can have different levels of infinity, but it's apparently true. In a horror game is, how many unique permutations are there of the digits of the cardinality of the power set of a set with the first perfect and happy number of elements? They're throwing like the entire math vocabulary at you there. A power set, isn't that like the set of all possible subsets of a set? It's something like that. And perfect numbers, that's the one where like their factors add back to the actual number. Yeah, you can have sets of sets, unfortunately. I don't know what a happy number is. Are all the other numbers sad? The power set of a set with 28 elements has a cardinality of that. Is that 28 factorial? That's probably too low for 28 factorial. Okay. Yeah, there's a few sub-problems in that one, I guess. Is this similar to what I'm doing? Kinda, but not really. That makes me think a bit more of like combinatorics with counting things. But yeah, I don't know exactly how to classify that problem. You'll be doing it? Well, good luck to you. I hope I never have to do that. Number of elements of each order in a cyclic group. If D is a positive divisor of n, The number of elements of order D in a cyclic group of order n is phi of D. So wait, why? Oh, they're just saying like a special case with U of n, I guess, but it is true in general for. Oh, wait, they're saying for the actual group, not for a subgroup for U of n. Okay, I guess. I don't know. If D is a positive divisor of n, the number of elements of order D in a cyclic group of order n is phi of D. Okay, fair enough. You know, you're in for a lot of fun when your book is so advanced it starts with like, ZFC is not strong enough, so we need to add this axiom. Oh gosh, I forget what ZFC is. I know I've looked it up before. Why would you want to access my location, Google, for this? You once looked in an infinity category book and they started with that? Oh, okay. It's just a set of axioms that you can start with. With the axiom of choice. Dun, dun, dun. The most common foundation of mathematics. Okay. Oh, and ZF is ZFC without the axiom of choice. What the fuck is a set? That's the weird thing about sets, is that the actual definition of set is just, it's any collection of unique things. So there's no duplicates. The things that you can then do with that are crazy, but that's really all there is to it for the actual definition of a set. And trying to like prove things with it are super weird, but yeah. I think you need if you do normal math. Makes sense, yeah. As in everything that's not logic or really large stuff. Okay. And hey to Pele over on YouTube, how many ways can you draw a straight line from a set of cards? What do you mean by drawing a straight line? Like how many different orders are there for that line of cards? Five cards in a row, like two. Oh, okay. So are you using the entire deck of cards, or is it just how many ways can you make a line of 5 cards? You're using all 52 cards? Okay. Or, sorry, so I know the deck has 52 cards. Let me... Thanks for lurking, Thunder. So if you're making the straight line out of all 52 cards, so like, you know, you have a card here, a card there, a card there, a card there, I'm gonna say dot, 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 all the way out to like 52, we can do that problem. Or are you only using 5 of those cards at a time? Just use 5 cards? Okay, cool. Thank you for clarifying that. So the way that you do this, every card in the deck of cards is unique, so we don't have to worry about duplicates or anything like that. That makes the problem a little bit simpler because we can just ask ourselves, for the first choice, how many options do we have? And that's 52, because there's 52 cards in the deck. For the second slot, how many options do we have? Well, we had 52 cards, but we used one on the first choice, so now we have 51 choices. By the same logic, now we have 50 choices for the next slot. And then 49 choices, and then 48 choices. And now the trick is you just multiply them all together, and that's your answer. So 51 or 52 times 51 times 50 times 49 times 48, and that's work for a calculator. We can get the answer to. Hey Phobos, how's it going? It's this large number, 311,875,200. Can you explain why e to the I pi equals -1? Yes. I feel like someone who's more experienced with complex variables could give you a better answer. But I can give you my shot at explaining that. Are you familiar with complex variables, but simple? Or like just complex numbers in general? Yes? Okay. So there's 2 different ways that we could do this. We can do it geometrically, or we can do it using formulas. And I can show both ways. Okay, so I'll start by just doing like graphically, I guess. So e to the I pi is a complex number in exponential form. And a complex number in exponential form, whatever your coefficient is, which we have an invisible 1 here, is your radius. Oh God, I can't spell. And the pi here, or whatever is the coefficient of the I, is the angle. And if you know polar coordinates, this is everything you need to graph it, or even if you know the unit circle, this should be somewhat familiar to you. So pi is an angle in radians. In degrees, it's the same as 180 degrees. And we measure that 180 degrees as starting from the positive x-axis and going around up 180 degrees. So we end up on the negative x-axis here. So this is, I'll just draw it. Pi, or 180 degrees. And then we know this is the direction we want, and we go our radius 1 out from the origin. So I'm just going to say that's length 1. And that happens to be -1, so right on the x-axis. So that's kind of like the geometric interpretation of it. I feel like there's maybe a more fundamental thing about why that actually works that I would have a hard time explaining. But that's how you interpret a number like e to the I something. The coefficient is the radius, and whatever's multiplying I is your angle. There's a different way that you can do it involving formulas, which is you can use Euler's formula, which is e to the I x equals cosine x plus I sine x. Sometimes it's theta or any other letter besides x that you want, but I'm just using x here. So we can apply this formula to e to the I pi and expect to get -1 out. So let's do that. So e to the I pi is cosine of pi plus I sine of pi. If you know your unit circle, cosine of pi is -1 and sine of pi is 0. So I times 0 is just 0, and we end up with -1 only. But again, like actually why that formula works is something that I had a hard time explaining. My natural complex variables is kind of surface level. But oh, the Taylor series explanation too? I bet there would be, yeah. Hey, Stooky. Good morning to you too. So I hope that makes sense, but simple. It's always a little hard to explain these things when I don't always know like everyone's like comfort level with math. So if I went too quick on one part, or your question is actually slightly, or your question is actually something different, please let me know. And Pella is saying, oh, I'm glad to hear that that helped, but simple. If you play a game of poker and get a straight, it has to be like 2, 3, 4, 5, 6. Oh, I see what you mean now. Okay. I misinterpreted when you said straight line. Okay. That's a good question. Let's think about it. So basically the question is, how many ways in 5-card poker, how many ways is there to get a straight? And I think we're gonna have to think about cases here. Let me actually put this up on the screen. Okay. So again, we do have 5 slots, but we have to do a bit of thinking about these 5 slots. So for our first slot, we still have 52 choices. That part hasn't changed. But what card we get here is going to determine how many possibilities there are for the rest of this. So just let's look at the lowest possible case. If we draw a 2 for our first one, we have to draw a 3 here. There's no other way that we can make a straight with this, because I don't think, yeah, I don't think you make a straight like with like an ace and going like backwards to the other end of the deck. So if we draw a 2, this is the only way we can possibly make a straight. Same with a 3. 5, 6, 7, and so on until we get, I guess, to 6 as our first card. Because now if we have 6 as the first card, I believe we could have 7, 8, 9, 10, or we could have 6 going down in numbers, 5, 4. Well, this would be the same case. No, this is the same exact case as here, so we'd be double counting if we had counted this one too. We only want to go up then, I guess? Okay, so that would simplify things if we don't have to actually consider this. And I don't think we do. Because for the sake of poker, this isn't substantially different from this. Because the order is irrelevant. Okay. So that means I'm going to put a dot, dot, dot here. Because, 2, 3, 4, 5, and then 6. And then I think we're fine with this logic up until we run out of slots. Like, let's just try it with a jack, because I'm not sure we're at the exact point where we'll run into an issue. So if we draw a jack as our first card, we can go queen, king, ace, and then we have no 5th card to put into the straight, because I don't think a 2 works. I might be misremembering the rules of 5-card poker, but I don't think a 2 gets you a straight. And hey to YKAP. I am correct about that? Okay. Oh, true, we'd have to consider different suits. Yeah, because we're allowed to mix and match the suits, aren't we? So we definitely have to start our straight with 2 through 10. But, so that's part of the problem. Or that's part of the problem solved. But you're right, we do have to deal with the different suits, because I don't think a straight cares about suits. Ace is the biggest and the lowest. Oh, good point. I forgot about that. So our valid first choices are ace, 2, 3, up to 10, which is I feel like that's just gonna be 11, but I'm gonna count on my fingers. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Never mind, it's 10 choices. See, that's why I count on my fingers. So we have 10 valid choices for the first card, ignoring suits. Now, how do we deal with the suits, I guess? If we did 52 and we subtracted out the ones that don't work, there's probably a better way to do it, but this is the way that's coming to mind for me. We have 52 minus, the ones that don't work are jack, queen, king, jack, queen, and king. And there's 4 of each suit of those. So what do we do? 52 minus 4 times 3 equals 40. Oh, and that's 4 times 10. So, okay. That means yeah, no, that's actually even simpler. Just, if we have 10 cards ignoring suits for valid first choices, then we do 10 times 4 is 40 possible first choices. Like a base 4 number in 5 digits. Oh, you probably do it like that. You have a problem with integrals by KAP. Yeah, sure, feel free to post it there in chat. Or it's easier, you can put screenshots in my Discord. Okay, so we have 40 valid first choices. And then for the next one, we have 4 valid choices because each first choice, it has to be followed by exactly 1 card ignoring suit, or 4 different cards if we do account for suits. In that one, it must be followed by another unique card which has 4 different suits, which has another unique card with 4 suits, and then another unique card with 4 suits. So I think we're doing this. 40 times 4 times 4 times 4 times 4. Is that too much? No, that might be what we need. I'm not the strongest on these types of problems if you can't tell, so. But that seems like it'll give a reasonable sounding number. You think it's correct? Okay. Ten times 4 to the 5. Yes, is another way of saying that. And that will get you 10,240. So I think that's my final answer. No worries. Yeah, it's kind of weird that Wolfram didn't actually give you the actual, or doesn't give the actual number. They give you the number in many different formats, but not the easiest one to read. Probably because they think this is something like scientific notation, but. It's, yeah, YKP, I'm happy to look at your problem too. And so yeah, Phobos, your interpretation is like how many base 4 numbers are there of 5 digits? There'll be a lot to count manually, but I assume there's a more convenient way to get that. Would it just be 4 to the 5th? How would you know to multiply? Oh, and then you'd have to multiply. No, why would you multiply by 10? I'm not sure with that interpretation how you justify multiplying it by 10, but I kind of see what you're getting at, I think. But yeah, you can definitely get a 4 to the 5th there. 10 valid. Oh, okay, yeah. Yeah, it is. I don't think I've interpreted a problem like that before. I mean, that way, depending on what you're trying to do. Or every time it was before the year 2000. I'm trying to think what, like, I learned, really, like, base 4 would get used in computer science. I know that, I mean, base 2, obviously, binary gets used a lot, and then hex would get used a lot. And sometimes, what's called, for 8, I forget what 8 is called, octets or something. I don't think I ever remember having to use base 4, but I didn't do all that much. It's represented with 2 bits. Octal, yeah. If you represent a base 4 number with 2 bits. Oh, okay, yeah. So you represent 0 through 3. Octal is 3 bits. Yeah, hex would be 4. Right? Yes. Oh, you know what, YKP, now that I think about it, are you asking in general how to solve integrals? Maybe you didn't have a specific problem. If you are still here, I'll link you to the site that I like, which is Paul's Online Notes. There's 2 sections on integrals in the Calculus 1 tab in the sidebar. And depending on what calculus you're doing, there's also in the Calculus 2, there's a section on more advanced integration techniques. I'll start by linking just to this first one on integrals, though. I'll put it in the YouTube chat there. Nibbles are 4 bits? Oh, yeah. Oh, wait, am I thinking of bytes or... No, 4 bits gets you 2 to the 0, 2 to the 1, 2 squared, 2 cubed. So you can do 8... No, you can represent 16 numbers with 4 bits, right? I'm getting mixed up on what this stuff actually means now. So I feel like I represent nibble. Oh, okay. Dude, it's been way too long since I've actually studied computer science. I get mixed up on such like basic things now. Uh, what was I doing here? If D is a positive divisor of n, the number of elements of order D in a cyclic group is of order n is phi of D. Depends only on... Yeah, okay, so... That's a weird fact right there. Z sub 8, Z sub 640, and Z sub 80,000. I'll have 4 elements of order 8, because 8 is a divisor of all of these numbers. It's kind of cool. So no formula for the number of elements of each order for arbitrary finite groups. Still something important in this regard. The number of elements of order D is a multiple of phi of D. Oh. For any prime p, phi of p to the n equals n, I assume? Oh, never mind. Equals p to the n minus p to the n minus 1. Really? Phi is the number, or all the integers up to this power of a prime that are, oh, I was doing it backwards in my head. All the numbers up to that are relatively prime to that number. So it's going to be every number before p to the n except for p squared, p cubed, dot, 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 p to the n minus 1. Which I guess is where this formula comes from. No? Well, I don't know. So prime to p to the n means not divisible by p. I feel like I just said something smart, but now that I think about it, I don't know if I actually understand what I just said. Relatively prime to p to the n means not divisible by p. Yeah, because the only thing that can go into p to the n is p itself in powers of p. And I'm trying to figure out how much, like, there are generally p to the n numbers before p to the n, or I guess p to the n minus 1, to not include p to the n itself. And so if we take that and remove the powers of p, that should be way less. Why are you just subtracting n minus 1? I guess maybe that's the point of the exercise. But I feel like there'd be n minus 1 many numbers before p to the n that are not relatively prime to p to the n. 2p. Oh. Maybe that's what I'm messing up then. Oh, okay. Okay, that was the point of what you said at first, that I wasn't connecting. Can you try to explain an inhomogeneous differential equation? I can try, yeah. So, I'm not sure if the definition of homogeneous is the same whether you're working with like first or second order or really any differential equation as far as I know. But how you deal with an inhomogeneous differential equation depends on the rest of it. But if we're just going to talk about first order, what I want to... if you're just dealing with a first order differential equation, which means you only have derivatives, you only have the first derivative of y involved, there's no like second or third derivatives, you would say this is homogeneous if g of t is 0. If this thing is equal to 0 and everything else is multiplied by y or a derivative of y, you would say, I'm going to write this on the board. I feel like it'll be a bit clearer if I do. Like, I'm interpreting your question as what is a homogeneous differential equation? If you're asking how to solve one, I'm going to need some more information, I guess. Because that varies a lot by what the differential equation actually is. There isn't like a general thing that works for every inhomogeneous differential equation. So if we're just talking about first order, so just a question of what is, homogeneous versus not homogeneous. A first order differential equation that is homogeneous you can write it in the form y double prime plus p of t, just any function you want involving t or whatever. Oh my god. It's just y prime, not y double prime. Sorry. Equals 0. The equals 0 is the important part. So homogeneous is almost like a special case that behaves well. Non-homogeneous or inhomogeneous you have y prime plus p of ty equals some function of t now, q of t. That's the essential difference. And they could be mean and like give things to you mixed around, like t squared plus t cubed y minus sine of t ln t, just something weird, equals ty. So you might have to do some like manipulation of the equation to rewrite it into this format or that format. But if you do like move things around, you could find, oh my god, dude, that this one will be non-homogeneous. So it's possible that you have to like play around with it to be able to tell for sure. Y prime plus 2y equals 2x plus 3. Sure. Sorry if I said that a while ago and I just only now checked. So first order equations like you wrote there are nice compared to second order at least. Because I believe you can always solve them with an integrating factor. So you don't necessarily even need to worry about homogeneous versus non-homogeneous that much. And I was using t's, but you can also use x's just fine. It worked for first order linear equations is the important bit. And this one is linear. Let me just look at what's going on here. Okay, so I'll show you the way that I was taught to do these, which is with an integrating factor. Now I had this memorized as a formula, which is probably not the best. People who are better with differential equations than I am are able to just derive this and not have to memorize it. But for people like me, I just memorize it or I look it up like I just did now. So we usually use mu for our integrating factor, and mu is e to the power of the integral of whatever the coefficient of y is. It could be a function, it could be a constant. Right here we just have a constant, 2 dt. And that's just something that I have, or I would just memorize personally. Unless you want to really go through and like understand like why this is the way that it is, but in my differential equations class, I just remembered it. And this is important because once we know our integrating factor, let's solve for this quickly. 2 integrates to 2t. I don't think we need the plus C there. The integrating factor is important because we can now just plug into the formula. So the solution to the differential equation y is equal to 1 over mu of x. Oh my god. Sorry, I'm going to mix up my x's and t's. I'm used to doing differential equations, but with t. But you gave me one with x, so I should use x. But I'm going to get it mixed up, so I'm sorry about that. So the formula for the solution to this differential equation is y equals 1 over your integrating factor, parentheses, times the integral of the integrating factor times that function there, which I'll just call g of x. Dx, and then I'm going to write plus c like prematurely on the outside here, because this integrating factor does have to multiply with the constant of integration that you get here. So let's plug things in. Mu of x is e to the 2x. Our g of x is 2x plus 3. Now we just have an integration here that we have to solve. It's going to be integration by parts. But this will become a normal calculus problem. And hey, Layla, Ali, calculate the angle in a triangle. There's a bunch of different ways to do that. Do you have, is there a particular rule, like law of sines, law of cosines that you're trying to understand? Or you're working with right triangles, or I need some more information there. I'm going to distribute the e to the 2x with the 2x and the 3. Do we have a trick here? No, we don't. So this part, 3e to the 2x, we can integrate directly. This part here, we need integration by parts for. So I'm going to do that separately. I'm going to take u equal to 2x dv. And integration by parts gets taught in a bunch of different ways. So if you're used to different letters or it being ordered slightly differently, just know that it's going to be the same thing. That's just the way that I was taught. We derive u to get 2 dx, and we integrate dv to get 1/2 e to the 2x. So we get y equals 1 over e to the 2x. And then we do uv minus v du. So 2x times 1/2 e to the x is x e to the 2x minus integral v du. 2 times 1/2 is 1, so we get just e to the 2x dx. This plus 3 e to the 2x we will integrate directly to get 3 over 2 e to the 2x plus c. Now we just have to integrate that term there, and then we'll combine things. That integrates to 1/2 e to the 2x plus 3 over 2 e to the 2x plus c. And we're nearly there. Let's distribute this 1 over e to the 2x in, and we'll get some nice simplifications here. The e to the 2x cancels with all of these, actually. So we get just x minus 1/2 plus 3 over 2 is 2 over 2, which is just 1. So x plus 1 plus c over e to the 2x. So I'd say that's the solution to this differential equation. And this technique works just as fine. Well, does it? I guess it doesn't. Well, does it work for homogeneous? It might be weird if you use it for homogeneous. If it is homogeneous, though, it's separable. So I probably wouldn't use an entering vector for something that's homogeneous anyway, and I feel like it might not even work, so. So I hope that makes sense. Hey, let me know if you have any questions on what I did. No worries. Oh, and let me, if you want to see some more examples and maybe work through them for yourself, I'll link you to my favorite site again. Or, sorry, site. I can't talk, but the site has a section on differential equations. So if you want to see some more of them, they have enough stuff on differential equations to get you through any like undergraduate curriculum, I think. See, I'm not sure exactly how this formula is going to work, but we can just not worry about it until we get to exercise 65, I guess. So yeah, you don't just eliminate the powers of p, you do have to eliminate the multiples of p. For relatively prime m and n, phi of mn equals phi of m times phi of n. Interesting. I don't feel like thinking about that too hard. Phi of 40 is equal to phi of 8 times phi of 5. Right, they skip over a little like sub-step in there where it used to say phi of 40 is equal to phi of 8 times 5 is equal to phi of 8 times phi of 5, but it's clear enough, I guess. Oh, so you can always break it down into the prime factorization and apply these two formulas to make it simpler. Okay. Relationships among the various subgroups of a group can be illustrated with the subgroup lattice of the group. This is a diagram that includes all the subgroups of the group and connects a subgroup H at one level to a subgroup K at a higher level with a sequence of line segments if and only if H is a proper subgroup of K. So it's almost like a tree diagram. But, I mean, you can potentially have things going like crazy left and right or like a bunch of different connections, but like lattice mention. Take critical. Yeah, sure. There's no other questions in queue right now. Hey, underscore. There are many ways to draw such a diagram. The connections between the groups must be the same. Typically, one attempts to present the diagram in an I. Typically, not always, though, I'm sure. Diagram for C sub 30 is shown in figure 4.2. Yeah, so we get some crazy connections here. So, right, one generates the entire group. So it's kind of interesting that you don't, like 6 is also a proper subgroup of 1, but we don't connect them. I assume because we just don't cross two levels at once. I mean, is 3 on the same level as 2 and 5? I guess it is, but it's kind of confusingly drawn to me. I guess you could express like how many generations removed from 1 is it? And you never skip a generation. Because you could always, I guess, connect 1 to all of these is the implication. Okay. Or I guess you could even travel along the path and see that because 6 is a proper subgroup of 2 and 2 is a proper subgroup of 1, 6 is a proper subgroup of 1. Okay. I'm just being obtuse. So yeah, 10 is a proper subgroup of both 2 and 5 because those are factors. Likewise with 6 and 15. So I guess you always start... Well, yeah, for Z-sub n, you'd always start with like 1 or whatever your like unit is, your generator. And you'll always end with the identity. Okay. Oh wait, we're almost at the end of chapter 4 here. I see you posted it, critical. It's 3 paragraphs, so let me just read these 3 paragraphs and I'll look at your problem if you don't mind. Precision of theorem 4.3 can be appreciated by comparing the ease with which we are able to identify subgroups of Z sub 30. Okay, yeah, I remember they used an example with U, where like you have the same order but different subgroups. Subgroups constitute a very narrow class of finite groups. We assume to know them. They play a role in the building blocks for all finite abelian groups. Ooh, okay. What's the instructions here? Critical? Is it just convergence or divergence? Ratio test? Okay. Sorry about that. Wrong pipe. I think so, underscore. It seems it should be convergent to me, just eyeballing it. How is this, the ratio test, oh, I don't know how the ratio test works with this. I would want to rewrite it first, at the very least. What is cosine n pi over 3? Pi over 3, it's going to be plus or minus root 3 over 2, I want to say. Oh, no, no, no. It's a little more complicated than that. All right, let's just apply the ratio test and see what happens. You're saying you also got convergent, but it's supposed to be divergent. That seems weird. Going from n equals 1 to infinity. You have to prove convergence aside from the ratio test. Interesting. So yeah, they do say explicitly use the ratio test on this. Okay. Well, let's set it up. I over 3 over n factorial. Okay. Well, first things first, let's unflip these fractions. N plus 1 pi over 3 over n plus 1. Oh, but I said unflip the fractions and I made my absolute value bar way too long. Times n factorial over cosine n pi over 3. So I just multiply by the reciprocal of that, which is the same as dividing. So we'll get a cancellation with the n factorial and the n plus 1 factorial. So with this n factorial goes away completely, and we're just left with an n plus 1 not factorial on the bottom. Okay. These cosines we have to deal with now, and I think the only way I can see to deal with them is to distribute the pi into the n plus 1. N pi over 3 plus pi over 3. N plus 1 cosine n pi over 3. And now we can use an identity on the top cosine, the sum identity. You're saying it's convergent as well, underscore. I wonder if the book is wrong. Because n factorial is way stronger than cosine, so I don't know what the book is on. So cosine of something plus something is equal to cosine of the first thing times cosine of the second thing minus sine of the first thing times sine of the second thing. And hopefully this leads us to something that isn't terrible. Sine goes to infinity. So cosine of pi over 3 is root 3 over 2. No. It's 1/2. What am I saying? Yeah, it's 1/2. And I'm doing it because we get a cosine n pi over 3 over cosine n pi over 3. But it's not quite that simple because we do have sine n pi over 3 to contend with. Sine of pi over 3, I should have written that in front. I'm going to write it over here though, is root 3 over 2. Okay. Now I'm going to split this fraction up into two different ones based on the numerator. So we get 1/2 cosine n pi over 3 over n plus 1 cosine n pi over 3 minus sine, oops, root 3 over 2, sine n pi over 3 over n plus 1 cosine n pi over 3. Okay. Ugh. As n goes to infinity, the cosines in this first fraction cancel. The one, I'm going to put the 2 in the denominator. Let's say that's 1 over 2 n plus 1 minus sine over cosine is tangent. This 2 can go to the denominator. Root 3 tangent n pi over 3 over 2 n plus 1. And that's all there. Okay, well, that one goes to 0. This one, I don't know about that one. What do I do with tangent of n pi over 3 as n goes to infinity? That's not very clean to me. Like, I would think that that diverges. Because tangent is like that. So as n goes to infinity or x goes to infinity, what part of the curve are you on? Does the pi over 3 change it? It probably does, but it just makes it periodic, which would still diverge. Huh. We're gonna do some thinking to figure out that second limit, because it's not necessarily infinity. Let me just make sure that I'm not crazy with the pi over 3 part would just scale the tangent. Yeah. So good luck saying what that does as x goes to infinity. It's just going to keep fluctuating. Which means L'Hopital's doesn't really apply. The quotient of cosines is bounded by some constant m. That's probably a better way of doing it. It might be invalid to cancel the cosines the way that I did because it could equal 0. No, I guess cosine equals 0 is at pi over 2, which we should never get from n pi over 3. What does Wolfram Alpha think of this limit? Plus or minus 1 and plus or minus a half? Okay. Indeterminate. Does the ratio test say anything about indeterminate limits? Because it's not necessarily infinity, but it diverges, I guess. But not necessarily to infinity, it just doesn't settle on one number. So yeah, this limit doesn't converge. Which makes you think we have to rewrite before you even start the ratio test. Maybe we should have rewritten the cosine. I don't know how you do that though. So before I ever thought about setting up the ratio test for the cosines, maybe we should have looked at the pattern of what cosine n pi over 3 is. One, two, three, four, five. So cosine, when n equals 1, cosine of pi over 3 is 1/2. Cosine of 2 pi over 3 is... It should be... Is it? Yeah, it's -1/2. Cosine of 3 pi over 3 is cosine of pi is -1. Cosine of 4 pi over 3 is -1/2. Cosine of 5 pi over 3, it's going to be +1/2, and then cosine of 6 pi over 3 is cosine of 2 pi is 1. And then for 7 pi, we're going to start repeating now after this. Can we express this as a function of n? Like, I don't think so. Not in a way that I can think of. Like, you can't rewrite as like -1/2 to the n or something. Oh, you're saying to like comparison and then ratio test? That must be what you have to do. I was hoping that that trick with the sum identity would salvage doing the problem directly. I think we would have, so we can't just do the ratio test on this directly critical, as you found too. And we can't even do that rewriting trick because it doesn't really follow a clean pattern. I can't think of a nice way to rewrite that pattern that we could evaluate in a series. So I think what we have to do is basically what underscore is saying. And what Phobos has put here, yeah. So how I'm thinking of phrasing it is, let's consider the absolute value of the series, because we know if the absolute value of a series converges, the original series must also converge. And now that we've taken this absolute value, we know that cosine is always going to be a half or 1 after we take the absolute value. So we can take the biggest number we get in this list, 1, and bound it above. That's a terrible sigma. That's like a 5-head sigma right there. And I think instead of having to do another series, I feel like we can just say that 0 is less than that and save ourselves some work on the lower end. You could also do what Phobos did and make that a 1/2, but, you know, do the same thing here, but with a 1/2 instead. I think 0 would give us less work and is a valid claim too. And why we're interested in doing this is because we found that we couldn't really work with the original series as it was written. But this series we can definitely work with. So we can prove this series converges with ratio tests. Then by comparison tests, this absolute value series converges. And then by absolute convergence, the original series converges too. So there's like three layers of tests here, but we do involve the ratio test, which I assume is their goal. So we set the ratio test on this thing. These both are always positive, so we don't have to worry about absolute values. And I'm going to unflip the n factorial. N plus 1. We get a cancellation here. The n factorial goes away completely. We have just an n plus 1 on the bottom. And that comes out to be 0. So the ratio test applies here. It says 1 over n factorial converges. So I'm going to write out the conclusion here. By ratio test, sigma n equals 1 to infinity, 1 over n factorial converges. By comparison test, n equals 1 to infinity of the absolute value of n pi over n factorial converges. Wait, we're supposed to get divergent, aren't we? That doesn't, I think the book is wrong. And I've dropped off the n pi over 3 part. I'm going to plug the original series back into Wolfram Alpha to make sure. Can this series, like, oscillate? Ooh. What does Wolfram Alpha say? Yeah. Is the book wrong, or are we missing something? I guess is the issue. A different chapter? Oh no. It is oh, okay, good. Wow, Wolfram Alpha, you can find the actual value of this. Root e cosine root 3 over 2 minus 1. How do you get that, Wolfram? So yeah, just to finish off the conclusion then. By comparison test, the absolute value converges, and then you probably want to look at what it's named in your book, because I don't think it has that well-defined of a name. I'm going to say by absolute convergence. This 1 to infinity of the original series converges. And that's the layers that are happening here. Adam Fighter, thanks for the follow. How's it going? Oh, I didn't. Converges. I left you on a cliffhanger there. So, yeah. I hope that makes sense. You have to do a lot of different things here. Welcome in, Adam Fighter. Oh, are you looking at the thing that, like the list of symbols I have in my Twitch description? I don't really know. I have it as a chat command too. Let me like bring it up and see what symbols it's next to. Yeah, I don't actually know what that means. In full disclosure, I stole that list from a subreddit that had that list pre-made, so I don't know what all those symbols mean myself. We could Google it. Transversality. How spaces can intersect. It's seen as the opposite of tangency. Huh. Differential topology. Okay, yeah. Me too. Huh. Ambient manifold. Okay, that's interesting. Are you gonna have more questions, Critical? I never learned them either. Manifolds. Not yet? Okay, sounds good. It's crazy to me, like, root E cosine root 3 over 2 minus 1. That's such a strange thing to get. I guess maybe it falls from this complex definition. How do you do a determinant in Wolfram alpha? Wolfram alpha is going to be weird if I use that tab again. Oh, sure. Critical. I would just enter the matrix. Take the blue pill, or whichever color it was. Enter the matrix, and it should be listed below somewhere. 4, yeah. So I don't know if there's an actual like determinant operation, but that's what I usually do if I want to get Wolfram alpha to do the determinant. There probably is something you can do like det, and then if you know Mathematica or whatever the notation is, there probably is some way to make, oh, apparently that works too. Oh, I don't know why mine works and yours didn't. Yours didn't. What's happening here? I got 2 questions. Are these the same instructions, Critical? Yeah, it can be a little weird to get Wolfram alpha to do what you want. Okay, good. N to 100 or 100 to the N. Okay, yeah, this is just going to be some more ratio test, which of course is what the instructions were. But this ratio test will be much cleaner. We don't have to go 3 layers deep for this question. Oh, what is that, Sigma? Oh my god. No, I'm erasing that one. Dude, I swear. I'm overthinking it now and making them even worse. Hey, Bob. Dawn doesn't draw. Yeah. Wicked Sigma. Sigma got into a car crash. Oh gosh. Okay. Yeah, this Sigma got like patched together or something, but anyway. Let's set up our ratio test. Like usual. n plus 1 to the 100. 100 to the n plus 1 over n plus 1 factorial. Big fraction bar. 100 to the n over n factorial. All right, unflip, get cancellations. These are all positive. I'm going to drop the absolute value bars. 100, 100 to the n plus 1 over n plus 1 factorial. Then this gets flipped, n factorial over n to the 100, 100 to the n. Okay, so we get our classic n factorial, n plus 1 factorial cancellation. We get 100 to the n plus 1 cancel 100 to the n, but we do have 100 to the 1 left over. 100 n plus 1 to the 100 over just n plus 1. Oh, hey, we get a little cancellation there. A teeny tiny one. N to the 100. I'm not missing anything, right? That went away. That stays. That canceled. Yeah, we're all good. So we do get a cancellation with n plus 1 times, or n plus 1 to the 100. So we get 100 n plus 1 to the 99, because we subtract 1 from the exponent, over n to the 100. Aha! This is where I would do my degree on top and bottom thing. So on top, we have a polynomial degree 99. And on the bottom, we have a polynomial degree 100. So because the degree on the bottom is greater, this is more important, and the denominator is getting very big very quick relative to the numerator. So big denominator, small numerator means this thing comes out to be 0. You don't want to use L'Hopitals on that. Yeah, so we get equal to 0, so it converges by the ratio test. The bits leader? Oh, yeah. With your 1 bit, Bob. Yeah, so because it's equal to 0, that's less than 1, so the ratio test applies, and it's convergent. Let's get the second series here. You can write it as 100 n plus 1. Oh, group them in the parentheses. Yeah, it's e to the 99, right? And that means, yeah, you'd have e to the 99 over infinity, basically. Like constant over something that's getting bigger and bigger. That's like if you want to be a Chad and prove that limit, that's what you would do right there. You know, the real Chad way is expanding out n plus 1 to the 99 and applying L'Hopital's 99 times. Hey, Cruz. How's it going? We gotta do ratio tests on this thing. So these are always weird to work with. In the denominator, they're like factorials. There probably is a factorial way you could write it as like a fraction of 2 factorials, but I don't, that's not that important. I'm doing good too, thanks for asking. Oh my god, the third one this stream. Hey, M&M, the other person said they had the best viewers. Like, what's with that? Who actually has the best viewers? So before I'm finding some general solution proved by induction. No, I want to translate this into sigma notation. So the thing I'm doing first is I'm figuring out what our starting index should be. So they give us the general form here. So I just want to slap a sigma on this thing, but we do have to figure out where n starts from. Technically, I mean, the ratio test doesn't really care where n starts from, but it's good to have. So if n equals 1, we get -1 to the 0 is +1, which agrees with the sign over here. You now do division with 0 divisors? How does that work? I thought the entire point is you can't do those. Pseudo division? Okay. Yeah, the instructions say to use the ratio test. I'm just trying to like make sure I'm thinking about this right, I guess. Diagonal? Okay. So yeah, if n equals 1, you get -1 to the 0 is +1. 1 factorial is just 1. 2 times 1 minus 1 is just 1. So this thing does come out to be 1. So I'm going to say our starting index is going to be 1. It's not really that important. But it's just good to make sure that you understand the general form of this series before diving too deep in it. Gonna make yourself food? Alright, see you in a bit, bub. Ooh. So I don't want to rewrite all the terms that they wrote there, but I'm going to copy that like nth term that they gave. Right, like that. So I was debating like what that n equals should be. It's not actually all that important though. Test reads introduced by John Cockle. Oh, James. Okay. So even though the denominator looks weird, we can still do the ratio test on this thing. So let's set it up. Yeah. I was debating if I should bother writing these negative ones because we have the absolute value anyway. But I'll still write it out just to show it. Okay, always good to remember the parentheses on the n+1 in this term here. It's an easy place to forget it. Now, this stuff over here is positive. The negative ones are the only thing that are going to possibly be negative. I'm just going to not think too hard and chop them off and forget about the absolute value. So I'm removing the negative ones because we're absolute valuing everything anyway. I'm going to distribute the 2 inside here. 2n plus 2 minus 1. And I'm going to flip the fraction and multiply. That's not flipping. It's the exact opposite of flipping. Okay. So we get a cancellation of the n plus 1 factorial and the n factorial to be just n plus 1. And then we have to think about this odd number situation. Let me simplify this part here before getting in too deep. To n plus 1. Okay. Oh, and then cheap viewers. You love free followers, primes, and subs? Well, apparently there's a link for you. I'll read that in a second, Corrupt. All right, so even though these aren't factorials, they do behave almost exactly like factorials in the types of cancellations that you look for. So these are both, so this one on top is every odd number multiplied together up to 2n minus 1. On the bottom here, it's every odd number up to 2n plus 1 multiplied together. The thing is, 2n plus 1 is an odd number. And the odd number that comes right before 2n minus 1, or 2n plus 1, ugh, I should just write this. Okay, so I'm not changing the value of this. I'm just going to write more terms of what this pattern is. So this is the odd numbers increasing by 2 each time. But we can also start at the end and decrease by 2 each time. And so 2n plus 1 minus 2 is 2n minus 1. That's 2n minus 1 is the odd number before 2n plus 1 is the important thing here. And conveniently, this matches that exactly, and they're going to cancel. So cancel, cancel. So we get n plus 1 over 2n plus 1. And so you could use L'Hopital's, you could do the degree of the top and bottom, or I think you like the n to the minus 1 over n to the minus 1 technique to bring it home. 1 plus 1 over n over 2 plus 1 over n. That becomes 0, that becomes 0, you just get 1/2. So, and that's less than 1, so by ratio test, that thing converges. Which one is equivalent? Shoot, I didn't see when you asked that question. I'm saying, oh, I think this is the same thing as that. I haven't changed the value. I just wrote out an extra term that was inside that ... No worries. Oh, I just realized I didn't cover up an important part of the problem. Yeah, that's the the trick with that type of pattern. Correct is saying, so let's say that ZDR of t equals r, where ZDR returns a zero divisor reciprocal of t. Oh god. Yeah, I don't have enough. I don't know what all that means, to be honest. Because and to be fair, I've never worked with like zero divisors before. TR returns the equivalent of 1. Oops. Sorry for bumping the camera. Critical, is that it from you for now? Squares to itself doesn't affect other values in that zero divisor plane through multiplication. No worries. Critical. T isn't 0, then R isn't 0. That's some weird stuff with zero divisors, like not being fully, like that you can still like work with them, I guess. Way to get to the end of chapter 4 here. T squared equals C, then T equals R. Okay. Oh gosh. Not a rule, but a consequence. Yeah. That's just, I don't know what to say other than like that's super weird, I guess. They're like unintuitive. Do I feel like going down the abstract out, like doing some abstract algebra problems, or switching to physics? T times TR equals T. Maybe, yeah. I guess so, yeah. I'm trying to wrap my head around it, but I feel like I'm becoming more stupid the more that I think about it. The more I've been doing math today in general, the slower my brain is going. Bunch of long set stream on this and a bunch of other stuff. Oh, okay. I was just thinking that I hadn't seen you stream in a minute. So we do a couple of algebra problems here. So a while ago, nearly a month ago, Penn Center said 1 through 6, 8, 9. So you do like 1 through 6 or something, depending on how long they take. Find all generators of z sub 6, z sub 8, z sub 20. I believe it's going to be everything relatively primed to 6 for z sub 6. Let's scroll up and refresh ourselves on like what was earlier on in the chapter. Oh yeah, it's going to be for each divisor of 6. Wait, no. There's so many theorems and corollaries, I'm getting them mixed up. I did stream last Friday. Oh. Holy crap. I hope you're okay. So I ended up in a really roundabout way with me getting Pittsburgh looking large piece of tree by your grandfather. That sucks. This might be what we want here. If we take a to the 1, it's generated by everything with a to the GCD. Well, no. The order of z sub 6 is 6. There we go. This is the one that we want. So yeah, it is everything that is relatively primed to 6. So generators of z sub 6 are 1 and 5, I guess. I'm sorry, my nose is running. I'm gonna go catch it. Okay. Yeah, and I say the generators of z sub 8 are 1, 3, 5, 7. Then z20, 1, 3, 7, 9, 11, 13, 17, 19. I don't know why I'm counting them, but suppose the groups generated by A, B, and C are cyclic groups of orders 8, 6, and 20. Find all generators of A, B, and C. Okay, so it's going to be A to the 1, or it's going to be A, and it's going to be A to the 5th. That'll still be b to the 1, b to the 3, b to the 5, b to the 7. Whatever numbers I just said for these, it's just a, b, and c to those powers. Those are test readings. Actually, to me, such a huge find. I don't like. It's a diagonalization. Are you just putting the values for each coefficient into a matrix on the diagonal, and is it zeros everywhere else, or like, what does that mean? I guess, assuming it's not very good with like linear algebra. Let's see elements of the subgroups 20 and 10 in Z sub 30. A plus bj diagonalizes to a plus b comma 0 and 0 to a minus b. Oh, okay. And I assume that has a lot of helpful properties when you diagonalize it. As soon as they lead with saying generated by 20, I think it'd be more natural to start with a smaller number, psychologically. It has all the properties of tesserae and it's reversible. Oh, I guess because it would be a system of equations, or... I can imagine that it would be reversible, but I'm like... For reason I'm actually like imagining the process, but I believe it, I guess. Oh no, I just scaled it. I don't know what I'm doing. That wasn't obvious. Exposes zero divisors as the value with any zeros in the diagonal. Oh. Radically simplifies the expressions. Gives you your new favorite identity. Is that something that's easily typed in a Twitch chat? What's your favorite identity? Yeah, let's see. P equals f of a plus b, x equals f of a minus b, f of a plus bj equals 0.5 p plus x plus jp minus x. Okay, and it's that last bit that you, or I guess it's all three of them together, but that's like the reverse process, I guess. For all elementary functions f. Oh, okay, never mind. I also think about like, so it involves a diagonalization, but it applies to all elementary functions. That is pretty neat. So we'll start with 20. 40 becomes 10. Then we get 30, which is 0. 10 is 10, 20, and then 30 becomes 0. The A be a group element of order 30. Oh, I mean, this is just gonna be the same thing. They're really hammering home this relationship between Z and any cyclic group. I guess we can say that's E. Okay, that's fair enough. I wouldn't say work, because there'd be more work involved, but that was a pretty quick one. It's a conversion to the diagonalization, right? Performing the operation, then returning back from the diagonal. Oh, okay. Literally what you derived from the natural log formula now makes so much sense. Oh, cool. Proof by induction works for all elementary functions f. Through code it seems to work, but you need rigorous proof. Okay, fair. That's cool. Three and 15 and Z sub 18. So these are inverses, so they're gonna probably generate the same groups. Oh, 10 and 20 are also inverses. And 3 and 7 are inverses here too. I'm not going to do all of these. I think for 6, we would say that a group element and its inverse generate the same subgroup. Which makes sense considering the definition of a generator. Let's do a couple more. Those were quick, so let's do a few more algebras. 8 and 9. Let A be an element of a group and let the order of A be 15. Compute the orders of each of the following elements of G. Oh. Oh. Yeah, Nikas, I'm yawning a lot today. No, I mean, I did get woken up by my phone like 2 hours early. It's like kept vibrating with some stupid like pop-up. So maybe that's why I'm sleepy. We need that one like my vibrate, yeah. I knew as soon as I said the word like vibrate that you would immediately connect it to vibrator. But you know, if you want to call my phone my vibrator, then you know, sure. I'm looking for the theorem that says something about like multiples. Yeah, you know, it's not wrong. Okay, the subgroups these powers of A generate are the same if and only if they have the same GCD. That's how these are organized. So back down here in 8, all of these 3, 6, 9, and 12 have a GCD of 3 with fit 15. Let's make sure of that, because only 3 and 5 go into 15. So these all have a 3 in common. And all of these are going to have the same as the order of 8 to the 3, which is 5. Because a cubed, a to the 6th, a to the 9th, a to the 12th, a to the 15 gets us to the identity. So that's order 5, yeah. So the answer for A is 5 for compute the orders. This one, they're similarly organized by the GCD with 15, which is 5. And they're going to have order 3 because 5, 10, 15. Now these are all... Do they give us every single power of 15? Or up to 15? No, they live off like 13, I guess. They live off the primes. Besides 2 and 5. But these are all relatively prime to 15. So they should generate the group and be order 15. Number 9, how many subgroups does Z20 have? Well, it has one subgroup for each divisor of 20. So 1, 2, 4, 5, 10, 20, so 6. List the generator for each of these subgroups. It'll be 20 divided by each of those. Oh, I was talking about how my phone was vibrating and like woke me up early this morning, which is why I keep on yawning. Oh, my phone isn't on the charger. Now that I glance over at it. And Nikas, being our resident like pervert, called it a vibrator. So the generator is going to be 20 divided by 1 is 20, or which is 0. That doesn't generate it. 20 divided by 20 is 1, which does generate it. Always keep your vibrator fully charged. Exactly, yeah. My phone doesn't really vibrate often, but I do play Screams of the Damned as your sleep ambience. Oh, okay. I thought it was gonna be some like metal music or something, which actually I could appreciate if you're falling asleep to that, but no, I also get falling asleep to like YouTubers like Markiplier and all that. But yeah, so it'll be generated by 1, 10, or yeah, 1, not 10. Wait. A generator for each of these subgroups. Yes, okay. So yeah. Don or Don? I forget how you pronounce that O, but honestly, I like it when vowels or like when like the accents and the umlauts or whatever randomly get like mixed in. By the way, I appreciate it, Nikos. Suppose that G is generated by A. And that the order of A is 20. How many subgroups does G have? Oh, it's going to be the same thing, but with A to those powers. That I'm slowly getting too lazy to actually write out. Okay. It's like, I get the point. It's fine. How am I getting pinged? Oh, I got ghost pinged? I wonder if this Discord was hacked. Anyway, people just really spamming. Oh, okay. Read it correctly, autocorrects, which means time in Turkish. I guess it's not something that's like incredibly terrible. And don or whatever means spin. Yeah. Hmm. Yeah, it does make sense with the autocorrect. Eight, I really want to figure out a way that makes sense to me, but I'm not going to do it on stream, I don't think. Oh, is that when you're taking a math class? I guess let's look at 9. Oh, that's when you're taking calculus, yeah. Oh well. So for number 9, a charge 2q is at the origin, a charge minus q is at x equals a on the x-axis. Find the point on the x-axis where the electric field is 0. With double D? Oh, do you use a different grading system there, or is that a typo? It was a good one? All right, let's do 9 then. If it has the Fembox stamp of approval. D squared? It's like, is that a good grade? We have like just D for a grade, which is one above F for fail. Really? So you do have the double letters. So we do like F. Some people don't do D minus. I think that depends on the school, but like F, D minus, D, D plus, C minus, C, C plus, B minus, B, B plus. D, D is the last passing grade, so maybe it's like a D plus or something. Okay. So we've got a positive 2 charge at the origin. And a -1 charge on the x-axis, a distance away. And a could be negative as well, I guess. Yeah, thank God you can't get an F minus. That would feel bad. Find the point in the line where the electric field is 0. So we can say well, you know what? The point where the field is going to be 0, I assume we won't get a 1 in the middle here, will we? Because these two charges are agreeing with each other. We'll have maybe 2 points on the outside? I'm just trying to get an intuition here. Yeah, an F plus wouldn't feel too good either. Oh, that's a weird, I guess it's like the pluses and minuses that we have. Two is a type 100, so he would give max 99? That's terrible. They say find the point on the x-axis for the field of 0. I think there won't be such a point out here, because I'm thinking the charge pointing inward from negative q is already going to be super weak compared to the double charge pointing out. So I assume we only get 1 point that's out here. Pi epsilon naught. And the distance from 2q to over here is just x. And this will be x minus a squared. And we're interested in where this thing equals 0. Am I taking a vibrator break? You know, we all need one sometimes. Riding on the bus and a buzzing sound started to come from your friend's bag. I mean, did your friend actually take the shaver out to prove it? Otherwise, that's just an excuse in my mind. We can multiply each side by 4 pi epsilon naught to get rid of those. We can divide out q. We can reduce this down to 2 over x squared minus 1 over x minus a squared. And let's get a common denominator, I guess. The denominator will never give us 0. We have to get 0 from the numerator. So we can delete the denominator entirely. Multiply out the squared, we get 2x squared minus 4ax plus 2a squared minus x squared equals 0. 2x squared minus x squared is x squared minus 4ax plus 2a squared equals 0. Do you factor? I doubt it, right? Nah, you don't. Probably not. We have to do quadratic formula, I think. 16a squared minus 4ac 8a squared over 2. You get 8a squared square rooted, so 2a root 2 over 2. 2a plus or minus, well, okay, goodbye marker. 2a 1 plus or minus root 2. But surely one of these is wrong, right? Doing it is wrong, I don't want to be right. He goes from bald to caveman hair every 6 hours. Check that oh, yep. What? Why don't things stay on the tray, dude? Ugh. Damn gravity, exactly. I only, dude, who even likes gravity? Electromagnetism is where it's at. So here's the thing. I need to stop fidgeting. Just keep my hands to myself. So are one of these invalid? 2 minus root 2 is still a positive number. So, if we plugged it in, would we get 0 for each of these? They said 1 point. I still have to check that last line? It's because the Earth sucks? Yeah, it literally does. I still need to check the last line. The 2 cancels with the 2. 2 cancel with the 2 to become 4. Okay, fine. Let's... do it the old-fashioned way. 2a plus or minus a root 2. Oh. What is that symbol? Besides a plus. I meant to write 2. That's less than 1, which reduces a. So it will be inside there, which I think can't be right. So we take only the positive. Because inside, I think, like, these two are agreeing with each other inside. They're not canceling. They only disagree on either side of the charges. And on this side, I think the negative charge is too weak to fully cancel out the positive. So I'm going to make the claim that x equals a times 2 plus root 2. For part A. Can I solve? Thank you, thank you. Let's look at part B. Vertical line passing the charge minus q. That is on the line given by x equals a. Locate x approximately a point on this line where the electric field is parallel to the x-axis. Ooh, where the y components cancel. That'll be fun. Okay. So we're doing that. And the y component for the negative charge will be relatively easy to calculate. We're going to do some trig for the y component of the positive charge. But other than that, it's going to be the same exercise. So I guess it's going to be sine theta. A sine theta. Well, okay. We gotta... The distance is a squared, I guess, plus y squared. Well, the square of the distance anyway. And we're going to slap a sine theta on that because we want only the y component. Plus, now from the negative charge, minus q over 4 pi epsilon naught. And I guess just y squared for the distance. And I don't think we need a sine or a cosine. Since we're... I hope not. And so I guess we'd want to parameterize stuff. Sine is equal to opposite over hypotenuse. Opposite is y. Hypotenuse is a squared plus y squared. I assume that's where we're going with this, which is where it's equal to 0. Opposite is y, hypotenuse is a squared plus y squared. I guess that's okay. And now let's get rid of the constants. Not being blocked. I'm about to be blocked by the problem. Okay. Common denominator, 2y cubed minus a squared plus y squared squared over y squared, a squared plus y squared squared equals 0. Again, we'll never get 0 from the denominator, so let's consider only the numerator. 2y cubed minus a to the 4th minus 2a squared y squared minus y to the 4th equals 0. That's a little on the terrible side. That's why they're saying at least approximately. Minus 2y cubed. I'm multiplying everything by -1. So that becomes plus 2a squared y squared plus a to the 4th equals 0. So, ooh, does it group? No, it doesn't group. Never mind. Yeah, I think that's where the approximately comes into play here. I was wondering where we're going to do the approximation, because like that didn't seem too bad to set it up. Ew. Check my sine theta? Really? Sine is opposite over hypotenuse. Oh, that's the square of the hypotenuse. I see. All right. Nice spot, Penbox. Classic 3/2 power. Okay, I think I fixed it. Saved. How do you solve that? I guess you can add that to the other side and raise each side to the 2/3. 2y squared equals a squared plus y squared. Oh, no, 2 to the 2/3. Okay. Four to the 1/3 minus 1 y squared plus a squared equals 0. Minus a squared. Hey, Ethan Quayo. How's it going? Let me give Fembox a save. You're okay? Oh, it's better than being bad. Welcome in. I'm just doing some setting out of a physics textbook right now. Work on part B, the problem that's in the corner. What's up with this though? I guess we can solve it for y. It does make sense for there to be 2 points. I'd expect it to be symmetric on the top and bottom. I guess. And it's an A, not a 9. Four to the 1/3 minus 1. Oh, really? No, please. I'm not too good with physics. So I'm not the best with physics. If you want, you can try me though. You can put it there in chat or in my Discord. Yeah, it's a nice problem. But trust me, no problem is too easy. I get stuck even on simple ones sometimes, so... This is 1.9. I do want to see what the book said about it. The answer to 1.7? Really? .9. 2 plus or minus root 2a? Hell yeah. The magnitudes are equal. That's okay. That's a nice way of saying it. Because I basically said that, but I didn't make quite that connection. And I'll look at that more in a second. Just, verifying my answer here. 2 to the 2/3. I wrote as 4 to the 1/3, but that's the same. Wait, they didn't do plus and minus? Oh, okay. Oh, hey, they're using IVT without actually saying IVT. Well, they say some intermediate y value. We consider instead the field at points. Oh, was that one of the coding problems, Phobos? Oh. I haven't read the actual question for that one. Let me look at Ethan's though. A cuboid of dimension 20 by 40 by 50 cm is placed on a table. The mass of the cuboid is 50 kilograms. Calculate the maximum minimum pressure the cuboid can exert on the table. Oh, I saw Gold working a problem just like this. It may have been you who asked it, to be honest. I don't remember. I need to look this up. Pressure exerted by a cuboid on a table. Because I don't have this knowledge offhand. I'm sure I can understand it. I just need to remember how this works. The max pressure is over the minimum. I mean, can't this minimum surface area? Oh, it depends what face. Okay. Yeah, I was thinking of an arbitrary cuboid, and it's like, well, you can get really small or really big. Okay. So, yeah, and the force is always the same, but the area is going to change. Sketch the cuboid on the table that exerts the maximum pressure. Okay. I think I understand what to do here. Now we do need... The mass of the cuboid is 50 kilograms. That's good enough. Okay. So we have a cuboid. Let me actually set the problem. Using the wrong formula for 1.7. Oh, that'll do it, I guess. Set problem on that. Okay. 20, 40, 50. $20, 40, 50. Very approximate cube here. Oh, we got to do significant figures here if they're giving us decimals. Ugh. We can do it though. Oh, we only have one significant figure though because of this part. Okay. So we have to think about pressure is force per area, or force divided by area. And the force of the cuboid is always the same because it's just the weight of the cuboid and nothing about the weight is changing. So the force is always going to be 50 kilograms times 9.81 meters per second squared. That's because of gravity. And that's a number for Wolfram Alpha that we'll do later. So the thing that we have to manipulate here is the area part of the formula. And if we want the most pressure, we want to have a smaller area because we're dividing by area. And if you divide by a smaller thing, you have a bigger number overall, if that makes sense. It's kind of a weird like thing to say out loud, but if you see actual numbers, it makes a bit more sense. So when looking at this cuboid, we have kind of three options for what to face down onto the table. We could have a 20 by 40 side that's like on the bottom or the top here. We could face on the table. We have a 20 by 50 as another option, which would be like the front and back as I drew it here that we could face it. And then we also have a 40 by 50, which would be the sides. So among these three options, we want both the maximum and the minimum, right? You're asking someone else that question to see if they got it? Oh, do you need me to explain the question, or I'm not sure I understand that? I'm happy to answer this question, but if you're already good, then let me know. We want the maximum and the minimum. Okay. Explain the. Oh, okay, yes. Sorry, I just want to make sure that I wasn't misinterpreting you. If you have any questions already, please let me know. Dude, I can't. So the maximum pressure is going to happen when we divide by the smallest area, like I was saying before. And the smallest area among these three options, we can actually just calculate it. Because for a rectangle, it's just length times width. So I'm going to say A for area is 20 times 40 is 800. I had to think about it for a second. The area there is 20 times 50 is 1,000. And the area for the third one is 40 times 50. Oh, 50, not 500. Which is 2,000. So the least area is this first one, which is 800. So I'm going to say these are all centimeters squared. Which we probably need to convert, don't we? We definitely need to convert it. Shoot, let's do a little conversion problem off to the side, I guess. I want to use this 800 squared centimeter because it's the smallest area, but this we have meters here, and we should probably make that match. So let's convert the centimeter square into meters square. 800 cm squared times 1 meter per 100 centimeters times 1 meter per 100 centimeters. I'm doing it twice because it's cm squared, so we need two of these to cancel it out. Is that right? Aren't we getting a really low number? I guess it's okay. Yeah, these are just small dimensions. Okay. So it's 800 divided by 100 is 8. 8 divided by 100 is 0.008 square meters. Sorry, too many, just 0.08. I moved the decimal to the left too many times. Oh, you're using 10 for gravity? We can do 10, yeah. And yeah, we can say it's a, yeah. Okay, and then we said the area is 0.08 square meters. Okay. I guess let's plug that into Wolfram Alpha. Just get the actual value, or just use a calculator there. 10 ms squared, that's the acceleration due to gravity. Which, I mean, I've written the same thing, but you have to do newtons per kg. The final answer should be Newton, no? Oh, that's the same thing. Yeah, I can rewrite it if that's how you're used to it. They do come out to be the same thing. 6250? Oh, okay. 500 over 0.008, or 0.008 rather. Yeah, I agree. Okay, 6250. But yeah, a Newton per kilogram is the same thing as what I wrote. So I'll put it in the terms that you're more used to. $62.50 newtons per square meter, which makes sense with force per area. Newton is a force, square meters an area. So I'd say that's our maximum pressure, which I guess they also want a sketch of. So we can do that, and then we'll get the minimum pressure. So I guess we'll start by drawing the table. That's a crappy table, but it's a physics class, not an art class. So we said the maximum pressure is when the smallest side faces down. So for the part that's on the table, I'm going to make it the smallest face. So I'm going to say that's 20. I'm going to draw twice of that to be 40 to make it kind of to scale. That's a little bit more than twice, but it's okay. 20 cm, 40 cm, and now the height will be 50. We can even exaggerate the height a little bit to make it clear. That's the biggest dimension here. So I guess I would draw something like that. If you're better at drawing than I, then you could draw it much nicer, but yeah. We can do the same exercise here for the minimum pressure as well. But since we want to minimize, we now want to choose the biggest face, which is 50 by 40 to face down. It's like your gaming PC. So the numerator stays the same because the force is always the same here. We do need to convert 2,000 square centimeters into square meters. Am I getting blocked by the problem? Oh, no, I'm not. Well, I kind of am, but times 1 meter squared, 4 zeros? Wait, 2 zeros, 2 zeros, 4 zeros. So, I mean, who cares? 3 of the zeros cancel, 3 of the zeros cancel. We get 2 divided by 10. 0.2 square meters. I think that's okay. Yeah. So plugging that in over here, 0.2 square meters. Ooh, that might be mental math. 500 times 10 is 5,000. Divided by 2 is 2,500. See if that's right. Yes? Heck yeah. 2,500? Awesome. So yeah, let me know if you have any questions on that. 2.5 kilopascals. Oh, pascals, I guess 1,000 newtons per square meter? Or no, 1 newton per square meter. It's a kilopascal. Awesome. Thank you for the question, Ethan. Oh, and for joining up with the Discord too. Let me know if you have any others. If not, I'm gonna go back to doing what I was doing before. Thank you so much for the help. No worries. It's good to get some exercise with these types of physics problems because I'm rusty on them, but the knowledge is in there somewhere. Two other ones? If you need help, I can try to work through them. Series converging super slowly. Do the same first few decimal places as the book did. Oh, what Fenbox is saying. If we get a minute, I'll take a look at 1.7. X caret 2. Oh, yeah, I think you do the double star, right? I forget what X caret 2 would mean instead. Determine the pressure at the bottom of the swimming pool of depth 2 meters on a day where the atmospheric pressure XOR? Oh, okay. The atmospheric pressure is 1 point. Thank you so much for the 2 months of Prime, Fenbox. I appreciate you. Turning pressure at the bottom of the swimming pool of depth 2 meters on a day with the atmospheric pressure is 1.1 times 105 pascals. How does this one work? Do we add the atmospheric pressure to the pressure due to the water? Oh, 10 to the 5th. Oh, okay, okay. Let me just see if my hunch is right here. Rho GH, where rho is the density of water. Oh. G acceleration due to gravity, H. Well, how are we using the atmospheric pressure? You do just add it on. Okay. So yeah, density of water times gravity. That's okay. Yeah, I had actually gotten to that formula in my head just using the units, to be honest. That's a Greek letter, Ethan. It's just a thing in math and physics that they love using Greek letters for everything. But you can even Google Greek letters. What website do I usually look at? Oh, what? What? Ugh. It was this one here. So yeah, this is a list of the upper and lowercase Greek letters. exactly. Theta is also a Greek letter. It's like rho is right here. Theta is right there. Yep, pi is Greek. So there's a little site if you want to like look at it for yourself. They have the pronunciations too with little sound buttons. Yeah, alpha, beta, gamma, delta. Those ones we probably heard before. $10. I don't know. Phi or phi, like I was taught to pronounce everything wrong apparently when I went to college. Cyrillic for new symbols. Call it phi. I've heard it both ways. So like I was taught to pronounce so during the exact analysis class we pronounced it C. I was taught to pronounce it Kasai, which sounds terrible. Wait, you prefer phi in Ugh. That still won't stop you from giving me crap for it, which honestly I kind of respect that. Okay. So, during the pressure of the bottom swimming pool of depth 2 meters on a day when the atmospheric pressure is 1.1 times 10 to the 5th pascals, the density of water is 1,000. Okay, so what we're going to do here is we're going to say that the pressure is equal to the pressure due to the atmosphere plus the pressure due to the water. So the pressure due to the atmosphere, they just give us that in the problem, thankfully. That's 1.1 times 10 to the 5th pascals. The pressure of the water, we got to do a bit of work though. We got to use the equation P equals rho G H. That looks like a Q. Where rho is the density of water, G is the acceleration due to gravity, and H is the height of the pool. So the density of water is 1,000 kg per cubic meter. The acceleration due to gravity, we said, is 10 meters per second squared. Kg, or newtons per kilogram is also fine. I think maybe we do want to do newtons per kilogram. Yeah, we probably do. And you even said that before, so I should just keep it all as newtons per kilogram. Then the height of the pool, we said, is 3 meters? 2 meters, okay. Bee is also a great song by Fish. I don't think I've heard it, or at least not by name. Use a different formula? Oh, what's the formula, Ethan? Also, hey, Dr. L. If you just post a screenshot, you can do it in like the math discussion channel or something as well. Pressure in a fluid in pascals is the density of the liquid in kilograms per cubic meter times the gravitational field strength times depth. Oh, okay. So it's the same formula, but it's different symbols. I'll rewrite it in the way that your teacher has it, but each of these symbols means that like same thing. Pressure in fluid in pascals is equal to yeah, exactly. So rho in your formula was the density, gravitational field was g, and the depth was h, as Fembox was saying. But it's completely fine to write it that way too, and I don't want to confuse you with symbols that you haven't seen before, so I'll try to avoid them because the math is still the same. So we have 1,000 kg per cubic meter times 10 newtons per kilogram times 2 meters height, plugging into the formula that you gave. But yeah, there's no wrong answers there. Just a different way of saying the same thing. So if you do this, that's 10,000 times, that's 4 zeros. So you take 2 and you add 4 zeros. 1, 2, 3, 4. The kilograms cancel. One of these cubic meters cancel with that meter, so we get newtons per square meter, which is a Pascal. 20,000 pascals. Okay. So now let's come back to that formula and plug things in. So the pressure is 1.1 times 10 to the 5th pascals plus, I'm going to convert 20,000 into scientific notation, 2 times 10 to the 4th. Should I even, maybe that's bad to convert to scientific notation. Maybe I should make it not scientific because the numbers are small enough. I'm going to say that 1.1 times 10 to the 5th is the same as 11 with 4 zeros after it. So you can move the decimal to the right 5 times. Pascals. There's a comma there. Plus 20,000 pascals. So 2 plus 1 is 3, so 130,000. I'd say is our final answer, and let's put it back into scientific notation, I guess. To the 5th. Oh, your teacher never used it. Okay. Function of death only. Yeah, that is weird, Dr. L. Oh, we can do it in scientific notation too. It's just a little bit like weirder to me because I'm not as used to it. I guess we could also say 1.1 times 10 to the 5th PA plus 2 times 10 to the 4th PA. Like, you could factor out a 10 to the 4th, I guess. I don't know if there's a more convenient way to work with scientific notation than what I'm about to do. But you could factor out a 10 to the 4th from each of these and say times 10 to the 1. And then that's just a 2 there. 10 to the 1 is just 10. So 10 to the 4th, 1.1 plus, or sorry, 11 plus 2. Ten to the 4th times 13. So now we just need to, 13 isn't quite in scientific notation, so we'll make it 1.3 and multiply it by 10. So 1.3 times 10 to the 5th now, pascals. I guess you could do it like that too. I don't know if there's a better way still than what I'm saying, but Oh, sorry, I might have misspoken there. Yeah, it's supposed to be plus 2 times 10 to the fourth. I talk too fast for my own good sometimes. But yeah, I know there's a better way to do scientific notation than what I just did, but I think if you were to do scientific notation, that's the best that you can do. Yeah. Either way, the answer should be 1.3 times 10 to the fifth pascals. One last question? Yeah, sure. Hit me with it. So much pressure. Sydney uses a solar oven to perform an experiment by heating up a glass of water. Ooh. This is like Newton's law. Oh, it's Newton's law of cooling. Is there Newton's law of heating? Energy gained by the water. We're gonna need to do some Googling here. Let me fix that part first, even though my camera's gonna cover it. Heating up a glass of water. Q equals MCT. Oh, thank you, Gold. Energy is mass times specific heat times temperature. That's, oh yeah, so that's part of the Q equals MCT thing as well. Okay. Following for specific heat, they'll get you there. Oh, fair. But I assume this is delta temperature. Don does STEM. Don tries to do STEM anyway. Don hurriedly Googles how to do problems on stream. Okay, so we get the energy. And then energy per time is power. The energy by the water has to determine the power. Okay, so we don't have to worry about the time yet. We have 400 grams. Okay. I think I know what to do here. Okay. So energy is mass times specific heat. Specific heat. And you say times temperature. I'm going to take that as times the change in temperature. I think is what we want. Delta T, yeah, okay. Fair enough. So the specific heat capacity is 4,200 joules per kilogram Kelvin. So we're going to do some unit conversions here, because we're given mass in grams and temperature in Celsius. Posted a question? All right, sounds good. Critical. This is, I think Ethan said this is going to be their last question, so I can get to you after. So we do have the 400-gram glass thing that we need to convert it into kilograms to match with the units there. Times 1 kilogram per 1,000 grams is 4 over 10 is 0.4 kg. And then, oh God, is it 273 degrees per Celsius to Kelvin? Celsius to Kelvin. 273.15. Look at me go. I remember things. So you do Celsius plus 273. Okay. So we have 18 and 26. Uh, 18 degrees Celsius is the same as 18 plus 273 kelvins. 18 plus 273 is 291. Yeah, 291 Kelvin. And then 26 degrees. 26 plus 273 Kelvin. You get a 9 there, a 9 there, and a 2 there. 299 Kelvin. Okay, I think we're good. Yeah, Fenlox, I think we could just convert the difference to Kelvin. I was thinking like that's not good if you're going from Fahrenheit to Celsius though, and I was like, let's be careful. But yeah, I think you could just get the difference in Celsius and then convert it to Kelvin, but I think it's potentially invalid if Fahrenheit is involved, so I didn't want to go there. So we're going from 299 Kelvin to 291 Kelvin. So that means the change in temperature is 299 Kelvin, because that's the final temperature, minus the initial temperature of 291 Kelvin is just 8 Kelvin, which is the same as if we just did it in Celsius. Actually, oh shoot, you're right. Yeah, Ethan, I did some extra work here. So this is where I'm rusty on these types of problems. When it's change in temperature, I could have just done 26 minus 18 and gotten 8. I was doing extra work because I saw a Kelvin there. I was like, okay, let's just get everything in Kelvins first just to be safe. But yeah, you could have just done 26 minus 8 to get your change in temperature. So that's my bad. So I'm not too good with the units, evidently. So I hope that I unconfused you. Yeah, sorry about that. That was unnecessary? Yeah, so that's my bad. Got to do some extra math there, I guess. But yeah, the more direct way is just to say change in temperature is 26 minus 18 equals 8. I did, yeah. Yeah, I just did a bunch of extra work there, but yeah, just if you're going from Celsius to Kelvin, that should definitely work. If it's Fahrenheit to Kelvin, I don't know about that, but 42, that's what we're getting to next now. Yeah. So now I think we're ready to plug into the equation for energy. I was making sure that we're given specific heat in joules per kilogram Kelvin. So we have our kilograms, we have our Kelvin, which is the same as Celsius in this context. So let's plug in. energy is mass, which is 0.4 kg, times 4,200 specific heat, joules per kilograms Kelvin, times the change in temperature, which was 8 Kelvin. That's 3.2. I'm not doing 3.2 times 4,200. I'm not that smart. Well, it's just 32 times 42, I guess. 3.2 times 4,200. 13,440. 13,440. The kg cancels the kg, the kelvins cancel the kelvin, so we get just joules. Okay, so that's the answer for the first part. Kelvin be replaced with degrees Celsius? Yes, technically. I'm being careful to match what we're given the specific heat. And the specific heat said Kelvin, so I would rather call it a Kelvin. But it is true that the change in temperature is the same in Celsius and in Kelvin. But I would make sure that these two units match here. And I don't know that specific heat if you change that to C. I assume it's the same, I just don't know that. It should be the same if it's C down there, but... It can in the formula? Okay. Power is energy per time. So yeah, so now we can figure out the time component. So the time, we start at 10:30, we end at 11:50. Right. So let's figure out how much time has elapsed between these two times. That's gonna be an hour and 20 minutes. One hour and 20 minutes passed. What units do we need the time in? I assume in hours? Like, is this a watt? Oh, we need it in seconds? Okay, we can do it in seconds. So yeah, 1 hour is 60 minutes. And there's 60 seconds in 1 minute. So the units cancel appropriately. So yeah, 60 times 60 is 3,600. Just from the hour, we need to convert the 20 minutes as well. Times 60 seconds in a minute. So 20 times 60 is 1,200. So we add these two together and we get 4,800, which does match with what you said. Okay. Yeah, I'm sorry, Ethan. I was just verifying that for myself, I guess. Yeah, you're absolutely right. So we do 13,440 joules in 4,800 seconds, which is work for a calculator. And that is what a watt is what Benvox is confirming. Thank you. 13,440 over 4,800. 2.8. Joules per second or watts is the answer for the second part there. So yes, sorry my explanation wasn't the best there, but I hope that makes sense. No worries. Thanks for coming by and asking them. I appreciate that. One last one? Yeah, what's up? Hey, Zappin. We have this last question from Ethan, and then Critical also asked a question, but Critical's question is going to take a little bit of time. So if you want to post your question, and if it's quicker, I'll do that one first. When they ask for the diagram of the largest cube, do they want the 40 by 50 cm or the whole cuboid? So, well, they wanted the cube with the largest pressure, right? Let me look back at the question. Because the largest pressure was the smallest face. Yeah, so they're asking for the cuboid on the table that exerts the maximum pressure. So I would sketch like the table in the entire cuboid, but for the maximum pressure, the smallest side should be facing down onto the table. Do you think you have to sketch the cube in both configurations? I'm scrolling up and looking at it. Here, actually, I'll paste it there in chat again. So yeah, yeah, for the maximum pressure, the 20 by 40 one should be facing onto the table, and then it'll be 50 tall. So I assume they want you to do like a three-dimensional drawing. So, I mean, maybe it depends on the class. How many of the questions they want you to like draw it three-dimensionally. But like, what I think they want is like you literally draw a table like that, or you know, maybe not quite as bad as I'm doing it. You know, this leg just shouldn't be there at all with perspective, right? I don't know. Anyway, and then like facing down onto the table is your 20 by 40 side. And then it goes up by 50. And so I would label each of these dimensions to make it even clearer. Like this is the exact sketch that like I would give to a teacher in how I'm interpreting this problem. But like like the 20 by 40 side is on the bottom, is the important part. I think they want you to draw the entire cuboid, but they want you to make sure you know the 20 by 40 part is on the bottom. So I thought what I draw is the entire sketch. Like I wouldn't do anything more in how I'm interpreting the question. Like you could draw it just like two-dimensionally. If that's your table, you could put like 20 by 40 right there. But that's just like a two-dimensional like impression, I guess. I think they want the actual like three-dimensional perspective, but that is like just like that's just the base on the table there, I guess. If that's what you're referring to. I I think they want the one on the left, but the one on the right is the same idea. If you flatten it out at least. Okay. Yeah, you're the one who's in the class, so I go with whatever your instincts are saying. Zappin, what's your question? I don't see anything in the Discord, or if you want to type it out there in chat. In the meantime, let me erase the whiteboard. Sounds good, Ethan. Thanks for asking the questions. Awesome. I appreciate it. Zappin, are you still here? I'll type in chat too. If not, I'll just move right into criticals question. See ya, Ethan, and thank you again for the follow. All right, well, if Zappin comes back, we'll take a look at their question. In the meantime, let's look at criticals. So, oh, okay, cool. Yeah, you're here, critical. I saw you said we have to do the root test. Okay, this one will be a quick one anyway. And I do see that we have 2 more on deck, but you did it? Oh, okay. What was the issue? Under the proper notation? Okay. Was it for evaluating the limit part, or? Oh wait, you know what? I want to see just in general. Okay. Just want to check one thing about the root test. How I do it? Okay. The absolute value goes inside. Okay. Sounds good. N squared plus 1. 2 n squared plus 1 to the n. All right, so to set up the root test, the limit as n goes to infinity of the absolute value of n squared plus 1 to n squared plus 1 half. To the n to the 1 over n. Let's make sure I'm doing this right at the absolute value. Hey, area. Oh, awesome. No worries at all. I know that life is busy, so thanks for saying hi and checking in on that. There's always the VOD that's available too, and the timing is better. I've seen Ian's Stuckey works from out on stream. Phobos may be doing some too. I can't remember, but yeah, I appreciate you like checking in. And of course, attendance isn't like mandatory or anything like that. It's just for fun. So, okay. So for this one, technically we do have the absolute value bars here. They pretty much always give you positive series, I think, though. So we're just gonna say this is always positive because the inside is always positive. Positive to a positive power is positive. So Let's drop the absolute value bars. And n to the n times 1 over n is 1. So we get just n squared plus 1 over 2n squared plus 1. So yeah, honestly, I would just skip right to this step if I was seeing this problem on a test. And to do it the way that I think you like to do it, we can multiply by n to the negative 2 over n to the negative 2. As n goes to infinity, 1 plus 1 over n squared plus 2 plus 1 over n squared. Those both go to 0, so we end up with just 1/2. That's less than 1, so by the root test, that original thing converges. Doing Let's Whale Saturday? Oh yeah, Phobos. Stream the problems all you want. I don't care. Yeah, there's like 82 problems or something, so we're not gonna run out of problems anytime soon. Skip n square root a to the 1 over n? Oh, yeah, I go straight to the 1 over n power. You can write it with the nth root. It's the exact same thing though. I would say it's unnecessary to start with the nth root, but if you like it, you can keep it. I just like doing with the 1 over n because it's a bit more clear how that cancellation actually happens to me. But that's a style thing. You can absolutely just keep it as an nth root. Sapin never checked in, unfortunately. Okay. It still hasn't. They still might. Oh. Okay. 1 plus 1 over n in parentheses to the power of n. And we're going to get that here. But I'm glad that you spotted that, like, E is potentially, like, coming up here, because for this problem, it absolutely is. So for E, you'd want it to just be n, but the root test is going to get us where we want to go. Exactly that critical, yeah. So if we apply the root test here, and of course you could write the nth root first if you want, but especially in a situation like this, I like seeing it with the fraction, or I mean, I guess you write it the fraction too, but it's just how I prefer to set it up. It's all a style thing. So we can make the same claim. This is always positive in the inside, so let's drop the absolute value. 1 plus 1 over n. N squared divided by n is just n. And now this limit we know to just be e. And e is about 2.71. So that's greater than 1, and this thing is going to diverge by the root test. So that one, it's a short problem, but you have to see the trick. Are you okay with that one? I going to start writing the next one. Okay, cool. Arctan n to the n. All right, let's apply our root test. All right, same deal. For n is going to infinity, so it's certainly positive, and arctan of a positive number is still positive. So the absolute value bar is unnecessary. Let's get rid of it. And normally I don't put this much effort into justifying getting rid of the absolute value. I might not even write it in the first place, but since it's part of the formula, I'm kind of explaining why we can get rid of it. A lot of times people just play fast and loose with the absolute values though, to be honest. But yeah, we get n times 1 over n cancels to arctan n. So now we have the limit as n goes to infinity of just arctan n, and this is where a graph can come in handy. So I like starting from tangent x, because that one's, it's something that I have memorized. These vertical asymptotes are at pi over 2 and minus pi over 2. And arctan of x is the inverse function of this, and when you do an inverse function, you reflect it across the line y equals x. So just for like demonstration, I'll draw the line y equals x. The important part is that as a result of this flipping, arctan now goes horizontal with horizontal asymptotes at y equals pi over 2 and y equals minus pi over 2. This is y equals arctan x. And so for very large values of n or x, or whatever variable you want to call it, we're getting very, very close to pi over 2. So I say this limit is pi over 2 as n goes to infinity. And so pi is 3.14 over 2. And I'm going to do a very rough estimate that is good enough for this purpose, that pi is about 3 over 2, just to make it even more clear what's happening. I would stop at this step, to be honest. But 3 over 2 is 1.5. Maybe write it a little bit bigger. And so that's certainly greater than 1. So I would say this one also diverges by the root test. I wouldn't say pi is about 3 in almost any other situation, but you don't need much more precision than that for finding out if it's greater than 1. And if you have a calculator, just use a calculator. Is the real answer, but if you have to do it by hand, that's kind of the cheatsy way. Yeah, there's no one else in queue to ask questions, so I guess you can keep them coming if you want. I might not stream for a ton longer, but I'll be going for a little bit more. I think Dan and Zach will be going tonight. Oh. Dan's doing wonderful 101. Never mind. Zach should be doing math help though. Oh, I see you posted the next one there. Sounds good. Another root test. Okay. Yeah, let's just apply the root test and unpack what we get. My stream and pen centers. Oh, nice. Well, thank you. Yeah, I mean, I like all their streams. We absolutely have different styles and different things that we prioritize, though. So, yeah, I guess. Okay, n equals 1 to infinity. Minus 2n n plus 1. Okay. So let's apply the root test. Okay. See, this one's a little bit funny because we do have a negative sign in there, so we can't play as fast and loose with the absolute value, even though we end up being able to. It's not going to change all that much. Raising something to well, yeah. I mean, raising something to a power should isn't going to. I have a hard time putting it into words. The result that we're going to get is that we can bring the absolute value bars inside the power. Like the 5n can come outside. I have a hard time explaining that in words. I'm trying to figure that out. And 5n times 1 over n is just 5. Because I think if you take anything to a power, if you do a negative number, it doesn't affect it, I guess. I have a hard time explaining why. Normal people just wouldn't question it that much. That is a weird thing to explain, but and I'm doing a terrible job of it, but if you have let's say -3 cubed is equal to -27, whereas +3 cubed is equal to +27. You could do the absolute value on the outside to be the absolute value of -27 equals 27. Or you could equivalently bring the absolute value on the inside to get the absolute value of 3 cubed is 3 cubed equals 27. I guess that's like it's not a proof, but it's an example of why you're allowed to bring the absolute value inside the exponent, because either way you'll end up with a positive number anyway in the actual number that you get out is going to be the same. So I'm kind of over explaining that part. Like I'm really beating a dead horse by going that deep into it, but I'm trying not to just say, obviously the 5 to the n can come out, or the 5n can come outside the absolute value. Because to me, it's just like, I would just do it without thinking about it. But of course, not everyone has done like a million math problems on repeat. So I don't want to assume that that's obvious for other people. Okay. So n is always positive, and we have a negative sign stuck out front. So if we want to take the absolute value, so then that means this thing inside is always negative. So if we want to take the absolute value, we can just chop off the negative sign. Oh, sorry. So we get 2n over n plus 1 to the 5th. There's two different ways we could approach this. I'm gonna distribute the power of 5 to the top and to the bottom. So 2n to the 5th over n plus 1 to the 5th. So break out the top. Because 2n to the 5th is the same as 2 to the 5th times n to the 5th. Now we're getting our equal degrees on top and bottom, n to the 5th. That's a 5th degree as well. And I realized we could actually do we could make this n to the negative 5 over n to the negative 5 thing work if you do like that way. It just looks a little bit weird, which is why I tended to avoid it. But that's actually, I'll show this way too, because it does work. It just takes a little bit more thinking. 2 to the 5th is 32. N to the 5th times n to the negative 5th is 1. This n to the negative 5, we're going to do something weird with it. This is the part that requires some thinking that I was avoiding, but I think it's good to see that it does work. So we have an n plus 1 to the 5th times an n to the negative 5. We can say n to the negative 5 is the same as n to the negative 1 to the power of 5. And then, oh look, we have two things to the power of 5. We can group them into one parenthesis since they're being multiplied. So it's n plus 1 times n to the negative 1 to the 5. And then you get 1 plus 1 over n to the 5. So that's a little explanation of why in the bottom here I'm going to write that this is actually 1 plus 1 over n to the 5. And then we have to take the limit as n goes to infinity. That part is 0, so we get 32 over 1 to the 5th, which is 32. And we did the root test, so that's greater than 1, so that thing diverges. Milk, 5-watch streak, thank you. So yeah, you could have also done the leading coefficient thing to do that limit, but since you've said that you had tended to do that with that n to the negative 5 thing, I just wanted to show that way too. Divergent, yeah, because it's greater than 1. A lot of divergent ones. Probably just because they want to give you some tricky limits to evaluate. If you have factorials, I think it is 99% of the time going to be the ratio test. I can't think of a situation where I would not use the ratio test when a factorial is involved. I just don't want to say always because maybe there's something I'm not thinking of. But yeah, the normal way to deal with factorials is the ratio tests. Like, it's really good at dealing with factorials. Are you gonna have more questions, or is that it for now? Just debating what I want to do. Hmm. Don't me post anything more critical, otherwise I'm going to go back to doing some physics stuff. Yeah, 1.7 would be cool to try and program something. Gotta figure out what the series is. Well, we could try and figure out what that series is, I guess. How does the example in the book set it up? Um, I think we just use this formula at face value. They made this formula from a three-dimensional case, but I think it's the same for this two-dimensional checkerboard that we have. It is different in 2D? Aw, man, I wanted to be lazy. Oh, they say per ion. And this is for the total potential energy. So I guess we would want that factor of n. I think otherwise it'd be, well, and not the 1/2. Okay. Or like this one the same. The actual calculation down here certainly won't be the same, but the calculation for the distance. So let's at least like, because at least the first part of this is just doing some math by hand. So let's do that math. Then programming it, I don't know if I'm going to do that on, like, I mean, I guess I technically could do it on stream. It's just going to be a big struggle as I remember what syntax even is. Okay, so it shouldn't make a difference if we start from a positive ion or a negative ion, right? Maybe a difference of sign. Even then, I don't think so. That's as far out as we'll go. I assume that'll be enough to figure out what the pattern is. Separation A. So if we know that's A, this is also A. So that's going to be root 2A. If we know... Okay, maybe let's start with a... We have 4 negative ions. Separated by A. So it's going to be minus E squared over 4 pi epsilon naught A squared times 4. And then we can deal with the positive to positive, which is plus E squared over 4 pi epsilon naught root 2A squared is times 2A squared. And then we have 4 things like that, right? And then going out one more layer, from this positive ion to that negative one, we have 2A on the bottom, 1A on the side. 4 pi epsilon naught. 2A squared plus A squared is root 3. So we get 3A squared. Is that A to the 4th? I'm messing my powers of A. No. It gets square rooted. Yeah, I think that's okay. 3A squared. Then we have 1, 2, 3, 4, 5, 6, 7, 8 ions like that. Now, so the positive ions, squared over 4 pi epsilon naught. So now we have 2A and 2A. So it'll be, oh, can we just do root 2A times 2? That would be easier. So it's going to be 8A squared. And then how many? 1, 2, 3, 5, 7, 8. Interesting. I might need to do another layer to really see the pattern, to be honest. Don't square the distances. Oh, shoot! You're right. Potential is just R. Ah. Dang. Got it. I got mixed up with field. So, oh, wait. That's not right. That only applies to the outer corners. 4. Up and down is just 2A. Did I do? I made the same mistake with the negative ions, didn't I? No, actually, that's going to be the same. Funny enough. 4 pi epsilon naught times 2a. And then how many? We have 4 of those. Okay. So we had to make some kind of claim. I guess we can separate it by negative and positive. Just figure out what the pattern is. Is the distance for the negative ions, I feel like that's root 1, that's root 3. The next one will be root 5. And how is the... Well... No. Because the one that's right there is going to be 3a. Dude, what is this pattern? You don't choose a rectangle like this. If you choose a rectangle like this, then you don't need to care about the pattern. You could just manually calculate it? Don't you need to actually like make the grid though? Or like, how does that work? Check that root 3. So I measured it as this positive ion to that negative ion. That's 2a. I probably messed something up. 2a squared is 4a squared plus a squared. It is root 5. Guess maybe there probably is an algorithm that can calculate these distances, right? Or some kind of way that we can construct this. Because we always have some that are perfectly horizontal and vertical. Yeah, you know, I don't think there's going to be an easy pattern like I was hoping for. Never mind. I thought we could like get some kind of like, or maybe a couple series in terms of n. But each time you go out another layer, I feel like you're getting a new right triangle. So it's probably not as easy as I thought. How would we? Because I'm imagining like a giant 2-dimensional array, but I don't think that's really. There has to be a better way. Gave up on doing it in MATLAB. We could focus on one quadrant of this and multiply by 4. That's a little bit of symmetry there. And we need to think about, I guess, what are we doing as we add each new layer? Okay. So like we can make a series for straight up and down and straight to the side. We could, it's almost like you get new diagonals, each with their own new series. Which is why that's why what I tried to do at first doesn't work. I thought we were able to get it all into like one or two series. So I guess we could code some kind of, we could just get a big 2D array, and in that array store like assigned distance. The sign symbolizes positive or negative charge. And the distance is just the distance, I guess, which we can probably calculate based off the indices. And Pythagorean theorem. I want to try it now. This is going to be terrible though, because I don't remember syntax or anything. It's going to take a second for this thing to run. How am I going to set my scene? Okay, maybe I'm just going to add a thing onto this. You got excited and killed the tab. I'm gonna try to code it. I don't think it's gonna go particularly well, but I feel like I have an idea of how I could maybe code it. So it's good enough for me. E&M one. You have one to share? Oh, okay. I mean, I think it'd be kind of fun to figure it out, though. Even though it's going to be painful. After you? Okay. I appreciate it. Even though, like, I could just look at your code, but, like, I've been meaning to get back into learning this a bit anyway, so it'd be good for me to try to remember how the hell Python works, or really any coding language. First off, how does a comment work? Okay, we do a pound. Numerical calculation of infinite 2D crystal electrical potential energy. Take n equals to 100. Size of ion grid to consider. Just because we have to do it, you know, we can't make n equal infinity. Conversion of Python download here. Oh, yeah, the runtime, like I initially, when I did my first coding stream, I think I tried doing like a browser thing that would run Python for you, but they had a pretty strict cap on the runtime for your program, so I wasn't able to accomplish all that much in it. What am I doing here? So we're going to consider just 1/4 of the infinite grid. I don't think Python has a block comment, or I don't remember. I fail at code critical. I minored in computer science technically. I'm so incredibly rusty on anything computer science though that it's gonna be sad. Run natively on the web? Oh wow. Like PHP does, I guess, or that's a close comparison I can think of for what that means. Interest will be at like in the browser. I guess like JavaScript is the better comparison. Wasm will save us. I don't know what Wasm is, I'm gonna be honest. I technically learned C++, yeah. I'm not too good with it. If you have like a question about it, I might be able to do it, or Phobos might know it, or if Jed's around, Jed would probably know it. You hang out with C++? Jed Levi. One of the mods around here. He's not always around, but if you have a coding question, if you put it in the Discord, he would probably see it. So if I just want to make a generic n by n two-dimensional array, how does one do that in Python? How do you even make an array in this stupid language? Oh, this is my best piece of code right here. Really proud of this one. No clue what's happening. These are all like old Project Euler things that I used to stream me solving. -1. Wait, so I mean, if I just want to initialize this thing and then fill it into the values, like how would I do that? Is a double slash integer division? I forget what that even means. For x in range and for y in range? Where am I storing these though? Or I guess I could calculate them one by one. I guess I don't need to store them. That's actually maybe a stupid idea, isn't it? Yeah, you're right. Yeah, we don't have to. We just need to store the running total, don't we? Okay, that's much smarter, Phobos. It's almost like you're good at this stuff. You use an array? Oh. Use NumPy. I honestly I forget what that even does. I know I've seen it before. Having some for x in range. So if we want to consider a 100 by 100 grid, I think we want range. Where does it start? Start defaults to 0, stop is omitted. I guess we want n plus 1. Or y in range n plus 1. Now, how are we going to figure this part out? So we want... I bet you there's some kind of, like, we want to figure out what, if it's a positive or a negative ion, then we want to figure out the distance. I'm not going to go in for much longer critical. I guess if you want, you can post another one or two, but I don't know how much more I'm going to do today. One more question? Sure. Do we want any x equals 0 if you're counting the one quadrant? Well, I was thinking, I guess x equals 0 is either the horizontal or the vertical direction, whatever we want to call it. I don't want 0, 0 for sure. But like, I guess x equals 0 is like the border of the quadrant that we do want to include, don't we? Okay, so you posted it. Is this still root test critical? Okay, good. I was like, that'd be a very mean root test. I'll include one border with the one quadrant. Visualizing that in my head. Oh, you're right. Okay. So we can do 1 comma n plus 1, I think. Okay, I completely missed that. Oops. Yeah, we wouldn't want to include both of the borders. So I just made that 1 comma n plus 1. I guess I'll have to work on it off stream or next. I guess next mission we'll be doing the group stuff, but I don't know. Let's do this question and then I'll do a bit more coding after until like Zach or someone starts streaming math, I guess. Oops, just moved my desk. What do we want to do for that one? You got to n ln n plus 1 over ln n plus 1. Okay, so you tried the ratio test. I would do the alternating series test before anything else on this one. because there's no factorials here, so an ln of n plus 1, it's not really a convenient identity that'll help us deal with that. So I'm not too hyped on the root test working out, and I think you found out why, because you get a limit that's really hard to do anything with. You could probably actually use L'Hopital's on that if you really want to make it work. But I think the alternating series test is going to be a lot simpler. So ln n over n is decreasing because n increases faster than ln n. And then we just set the limit as n goes to infinity of ln n over n. That's infinity over infinity, so I would L'Hopital's it. As n goes to infinity, 1 over n over 1. So that's just 1 over n as n goes to infinity, which is 0. So because it's decreasing and the limit comes out to be 0, I would say it converges by alternating series. Oh, wait. This seems like something that would diverge, though, right? No, it's alternating. It's okay. Yeah, no, I think it converges. If it was not alternating, it would certainly diverge, but... Yeah. I'm just looking at the criteria for alternating series tests again. Yeah, I was thinking of the harmonic series too. The comparison. So the thing that saves it from diverging is that it's alternating. Like that -1 to the end is what makes the difference there. Otherwise, this thing would absolutely diverge because it's like the harmonic series. But even bigger because we have an ln n on top rather than just 1. Okay. I am very intrigued by this coding thing now, so I kind of want to see if I can make at least a little bit of progress on this before I turn things off for the day. No worries, critical. And I'm planning to write out to Zach once he goes live, so there's going to be people doing math help out there tonight. But my mind is kind of on this right now, to be honest. I'm gonna... I shouldn't have made the grid that big. I want to actually have like a little grid here for reference, though. Okay, so I'm thinking x equals, we're starting x from 1, I guess. Or 5. And y is starting from 0. Okay. So, 0, 1, like this very first iteration of the loop, or sorry, 1, 0. This is a janky way that I wrote it, but actually no, it's just weird to get used to. This is the best way I can think of to write it anyway. So 1, 0, which is the very first loop this thing is going to do. We just want it to be 0. I was trying to think of like some of the special cases and let that inform and how the rest of this will be. Oh my god, that's number 4 today. We're back to being the best viewers rather than the cheap viewers. That's good though. That's progress. Okay, so I wonder if I wonder if I should think about special cases or just go straight to some special formula here. The distance, like, let's just get distance of this thing here arbitrarily. So we're going 1, 2, 3 down and 1, 2 to the side. So the y distance we can take it, or the y value we can take at face value. X we have to subtract 1 off. Distance equals x minus 1 star 2, I think, to square it. Oh, we're gonna need to square root it also. Y star 2. And I hope Python isn't gonna... Oh, do not do 1 over 2, 0.5. Hey, Exo Gaming, how's it going? And so how is this going to interact in our special cases? I guess if x equals 1, so this column here, we're going to get just the y value back out. And that's, I think, exactly what we want. And in the case 0, we do get 0 for the distance, which is good. Oh shoot, we have 3 issues to solve. We need to get the distance, we need to get the sign, and we need to get, well, no, never mind. I was thinking we need to get the number of ions that match that pattern, but we're taking care of that already. I don't need to comment that. That's obvious what that's doing. I was going to say get the distance. Fine. I'll comment it. Okay, how can we figure out the sign? You need, I guess, a pattern in the coordinates. It feels like it's some kind of mod 2 problem. Phobos might have actually given a hint before on this, was it? No, never mind. That was for something else. Yeah, so maybe we just like multiply the mod 2 of each coordinate. Like, what would that get us? So 1 mod 2, we might do like x minus 1 mod 2 or something, but like 1 mod 2 is 1. 1 mod... I want to subtract 1 off the x's. So what if we did sign equals x minus 1. How do you do mod in Python? Oh, per percent, probably. Then we're going to do, I guess, times? Let's just try times arbitrarily, I guess. And see where that lands us. Does this formula work or not? So if we do if we input 2, 1, we expect positive out. So we do 1 mod 2, well, never mind, we need to interpret this. Are we gonna map 0 to -1 and 1 to +1? I guess that's what we're doing. That's kind of, there should be a better way to do that, right? That's such a, yeah. -1 to a power might be better. Actually, maybe -1 to the power of this thing that I wrote. It has order 2. We're doing group theory now. Yeah. So if we give it the coordinates 2, 1, we're doing 1 mod 2 is 1. Maybe we might want to do a plus on the inside. Times 1 mod 2 is 1. So -1 to the 1 would still give us -1. So I feel like it's maybe a plus. Doing this, proof by guessing and checking, just like they do in group theory. So that would fix the 2, 1 case. Let's make sure it works for a negative case. So if we take this one right here, 2, 2, we would do 2 minus 1 is 1, mod 2 is 1, plus 2 mod 2 is 0. So we get -1 to the 1 is negative. So that would work. You get a 2 for the sign there. Oh, sorry. I mean, I was doing it in my head, but -1 to the power of this thing. Yeah, so I'm running this in like Windows subsystem for Linux is what WSL is, and I'm just doing that because I figured it's like an extra layer of safety if I'm showing this on stream, where it's locked into its own files, like system. Something like, oh, if I accidentally read the wrong file, I'm not gonna like show the wrong data or something. You really probably don't even need the WSL part. You just get VS Code and start doing Python. But I mean, if you want to run a Linux window inside of your Windows, WSL is a really easy way to do it. Okay, if I just arbitrarily say this formula works, because I checked 2 cases, so obviously it must work for every case. Negative sign, positive, have positive. Oh yeah. Not all of them are complete, but last summer I spent a fair few streams doing Project Euler problems. This feels like I'm already pretty close to getting a number out. So what are we actually doing here? We're summing 1 over sine times distance, and everything else are just coefficients of that thing that we actually care about. I don't know why I'm looking at the board. I don't have it written on the board anymore. Oh, did you used to watch Twitch Math? Well, we need this to be a floating point. I guess like 1.0. It won't dry for a while? Oh, fair, yeah. Because for the longest time, as far as I know, Penn Center and Obi were the only ones who were doing it. That's from what I heard from them. You're watching Math on Twitch? Oh, okay. Is this everything that I wanted to do? This feels too easy, right? It should be harder. Okay. Division by 0. Well, that's great. Oh, it's probably in that very first one. Yeah, I need to throw out the 1-0 case. I do want x equals 1. Okay. If x equals 0, and I hope that's how you do it in Python. Sorry, we want not equals. I did skip x equals 0 on purpose. I don't remember why I did that now. Oh! Wait. Crap, I don't think I set it up right. Yeah, 1 border per border innards. Is it shift tab? Okay. 0.40. That's a number. You can't tell me it's not a number. Is that a good number? I don't know. I feel like oh wait, I need to multiply it by 4. But I'm calculating the distance from 1-0. Is that right? No, yeah, you're right. So that's why I take out. Okay, yeah. So my comment here was wrong. It's basically what you got too. I mean, that ran super quick. We could slap another 0 on that thing. There's no way that I solved it that quick, right? Let's see what the answer was. I mean, if Femlux agrees, that makes me feel more optimistic. Let's go check the answer. Yeah, it's kind of a cool one, Dr. L. Probably that's like 585 or something. Nope. 1.7. I had the same mistake as you? No! What was it? That's not the right window. That's the right window. Didn't divide by 2. Did I double count things? I thought this was engineered so... What? Why are we dividing by 2? I don't think we're double counting pairs. Oh, the book answer says you have to divide by 2? Minus 808? So I messed up my sign. Oh, should I? I didn't change the sign to remove the x minus 1, I guess. Oh man, my comments being wrong is really like throwing me off. So I just took off the minus 1 from the sign, and then I get a negative answer. But yeah, I still have twice as much. I wonder why. Minus 807. And they say 808, so that's close enough for me. I need to understand why this is, though. It's probably more of a coding thing, right? Or how we set it up. Oh, wait. I did 1,000. Ignore some very specific ones. I don't know. So counting interactions from everything to one charge. Yeah. Oh, really, Fembox? There must be something weird with your code then. I figure there's almost certainly something weird with my code too, but I have Phobos to help me, I guess, which is an advantage. Opposing coordinate system with chosen indexes. Yeah, like I would think this. There's no way this is double counting things, even though it seems like it apparently is. Didn't use a rectangle like you did, and like the textbook did. You went out in a circle. Oh, that. I can imagine that you would have less precision like that, unless you need, or it'll take a lot longer to get the same precision. That's my guess, because you're doing 4 times the work. Or would it? No, I feel like you're not getting significantly different things for like the first ion directly above versus the first ion directly below. Should be the same number. So I think you're like, maybe you're wasting computing power. You gotta spend a lot more to get to the same precision. That's my weird guess, I guess, but it would have more of an effect in those ions that are the closest, but you're still getting the same number regardless. So I think, I assume that's why. I don't have to think about this harder, because to be honest, like 90% of what I just wrote here was trying things. Like, I want to update this comment and make sure I actually like know how my grid is working. Half an hour? Wow. That's crazy. I guess it would be, this is 10 cubed, and you would have, well, I don't know. That logic might not quite work. I mean, we can slap another 0 on. I bet it'll run pretty quick. Try to take all your memory? Oh, maybe that was a bad idea. Let's see. I mean, no, my CPU is fine. Let's see. Suspense is killing me. Oh yeah, let's take a look at how you did it. Thanks, I completely forgot about that. Did it run yet? No? Okay. Yeah, it did slow it down. Yeah, it still hasn't completed yet. I got my half on the window right now. Let's get what Phobos wrote though. Where numpy is np equals 2000. np dot arrange negative n to n plus 1. Oh, it ran just then. You do all quadrants. Okay. So that's why you're doing the negative n to n plus 1 thing. And I assume this is the arrange just fills it with every integer, but starting from negative n up to n plus 1, maybe not including. And then mesh grid is like a Cartesian product of these two things. Tried a bunch of different values to watch the result. Yeah, that's super weird, Fembox. Okay. R is the square root. Okay, so it's the distance of each of these squared. So does that? Oh, so this is how you got an array of all the, so you're storing these as an array. Wow. That's another mesh grid. That's the square root of the distances. Okay. Then Q is 1 minus, this is for your sine maybe? What's happening here? You're doing x plus y, modding it with 2. So you're getting their sum. It's kind of like what I did. You're taking the mod of it with 2. So you get either 0 or 1. That gets multiplied by 2. Then you do 1 minus that. Oh, that's clever. Wait, I did minus 1 star star. Am I going to get arrested? Or what's wrong with that? Oh, NumPy doesn't like it. Okay. So you have to do that kind of janky thing that's going to get the same result. Okay. What's happening here? R is equal to 0. Like, is this like an index? Oh, to ignore. Okay. And you set it to infinity, which I assume is going to give you 0 over here. Okay. So NumPy just sums over all these for you. Wow, this is convenient. So you're doing the sine divided by the distance, fair, and you've manually set 0, 0 to be 0. Wow. And that's where you just add in the division by 2 to make it match the book's answer. Is that the part of the book's answer that you didn't trust? Phobos can probably explain it better than I could. As far as I know, it's just a Python library that does a bunch of helpful math things. Well, that's super awesome. Thank you for showing me this way of doing it. I need to try some more coding things. I'm hoping that, well, I'm not hoping, but I'm expecting that in the next few weeks, the math questions will slow down a lot. And so I'll have more time to do some coding, more time to do the physics and algebra stuff. In terms of level 1/2 is needed. Yeah, same Phobos. I'm gonna have to actually read through the book's answer because I haven't actually read it yet, but I feel like we should have, like, the way we constructed it is fine. So I wonder if there's some kind of physics reason. Yeah, I think we'll wrap things up there for the day. It's more of a can you code problem. Yeah. I need some food. Let's go right out to Zach, shall we? It's not straight. Ah, sorry, there's 2 of me. Much better than 1. Probably not. Eats the 2i pie. Okay. Thanks so much, everyone, for hanging out. I should give saves to the both of you there. I miss out on giving out. I always miss out on giving out saves, but yeah. But hope you have a great night too. Tomorrow we're doing Plate Up with Pen Center and Talos, so I'm gonna be starting my stream late, and potentially Jed too. I'm not sure about Jed. And then Saturday we'll be doing some more physics reading group. So yeah, I'll see everyone around, and thank you all for hanging out. All right, bye.